There it is. All right, let's go ahead and get started. We'll do very quick introductions, name, organization, and interest in risk management or dam safety. I'm going to go down my list, and if you want, feel free to turn on your video feed so we can associate a face with the name. Bing, good morning. Would you like to kick us off with a quick little introduction?
Oh, sure. Good morning, everyone. Thank you, Rune, and for organizing this wonderful workshop. I'm Bing Chen. I'm a professor and associate in graduate studies with the Memorial University of Newfoundland with civil engineering and faculty of engineering and applied science. I'm also the director of the People Network. So my interest is more related to the emergency response. I have been working with especially energy sector, oil and gas industry in terms of oil spills, especially the offshore oil and gas development and shaping, how to develop decision-making tools, and also response technologies for emergency response, for example, marine oil spills. Thank you very much.
Thanks, Bing. Next on the list, I have Calvin. Good morning, Calvin. And if you don't do a self-introduction, I may be forced to provide one for you. No worries. Maybe since we have such a small group, I'll have the speakers kind of do introductions as well. So Ray, you're next on my list.
Rune, you hear me?
Yep, you're good.
Yep. Ray Chow, I'm with Duke Energy. So I'm in the operational excellence for regulated renewables. Regulated renewables is hydro and solar. So I've been with the company for probably close to 20 years and been doing operational excellence, which we hear about a little bit later on, for about 8 years. So my background is in nuclear engineering. So I have a lot of regulatory understanding and from that respect. So I apply a lot of the nuclear background to where I'm at today. So I'll just turn it over to you, back to Rune.
Great, thanks, Ray. Dell, you're next in the hot seat.
Thanks, everyone. It's nice to see you and a pleasure to be here. My name's Dell Shannon. I'm a senior vice president at Schnabel Engineering in their dams group. We have about 200 folks that think and worry about dams in North America, and so that's what we do. I'm also the current president of the United States Society on Dams, and will be for another year or so before the next sucker takes over. Dam safety has been dam design and dam construction and dam safety have been a passion of mine for almost 30 years now. I'm a geotechnical engineer by training and background, and got pulled into the dam world quite early, and have been fighting for its not only relevance but importance for a long time. These structures are extremely significant and impactful and need to be worried over and discussed, and so it's a pleasure to be here to talk about this topic with all of you.
Thanks, Dale. Jacob, you are next on the list. Would you like to do a self-introduction?
Sure, you bet.
Nice.
So I'm Jacob Mader. I work for the Irvine Ranch Water District in Southern California. I was recently appointed as engineering manager for the Dams and Storage Group. And the district is really kind of trying to bolster up our program. We're transitioning to a rhythm-based program. And so we're really trying to immerse ourselves into this industry and really produce a good program. So I'm excited to hear what you guys have to say today.
Great, thank you much. Bob, you're next.
Yes, good morning. I'm working here two different computers. So if you
Nice.
see me glance away, that's because the camera works on one and it doesn't on the other. But Bob Knowlton, VP of O&M Services and Technical Compliance at New York Power Authority. I've been here over 30 years. Was the dam safety engineer at one point. So have been involved in and around dams, most of my career. I trained as a civil engineer, so I think the great things about dams is you hit civil, structural, geotechnical, hydraulic, all of those aspects. So I really thank you, Rune, for putting this together, and for Denise for reaching out. I think it's a great discussion, and I get our topic, as we'll talk about later, is we recently adopted the Canal Corporation under the NIPA domain, and some of the challenges that we've had along the way there. So look forward to the discussion going forward here.
Thanks, Bob. Next I have is Natsuda. Am I saying that right? She's a student at the Berkeley School of Law. Is that the name? They keep changing the name. It's just Berkeley Law now, right?
Yes, good morning,
Okay.
everyone. Can you hear me clearly?
Yes.
Hey, my name is Natsuda Ratamani. I'm from Thailand, and Professor Faber, Daniel Faber, he is my advisor. So he introduced me to these programs, and it's so nice that you have this discussion. It's very related to my topics, because my working topics right now is about the dam construction in Thailand. I try to propose a legal and regulatory framework for dam and reservoir in Thailand. So dam safety is going to be part of my proposed framework to Thailand. Thank you.
All right, you attended the right event. We're going to set you off on the right path for safety and reliability.
Thank you so much. Yeah.
All right, Paul Schulman, you're next.
Okay, my name's Paul Schulman. I'm a retired professor, and I work with Rune and other colleagues connected to the Center for Catastrophic Risk Management. And I have, over 32 years now, been looking at systems that have hazardous systems and how they can be managed safely and reliably, starting out with looking at nuclear power plants, and then air traffic control and its commercial aviation. And more recently, looking at interconnected infrastructures of various types. And my current project is looking at planning for a potential M9 catastrophic quake based on the two-plate subduction, one subduction plate up over and under another off the coast of Oregon and Washington, and trying to see how people are planning for a quake of that magnitude and the accompanying tsunamis that will be with it, which is maybe a long way from reliability and safety as far as I could get.
And Paul, by M9, you're referring to a magnitude of 9.0, which is
9 or higher quake.
How many nuclear blasts is that equivalent to?
I don't know for sure, but every 300 years one has occurred, or more or less. And so that last one was in 1700.
Are you foreshadowing something for us?
No, I don't know.
All right. Tony, welcome. Would you like to do a quick little introduction?
Yes, good morning. Tony Williams. I'm the Assistant General Manager and Chief Engineer of the North Marin Water District in the sleepy town of Novato, California. We are the proud owner of an extremely high hazard dam. And I'm trying to get, my mission is to get our board of directors to realize what an incredible asset that is and what a potential liability that is. And I apologize, I'm a little casual this morning. I just saw your email last night, Rune. And by the way, you and I met, gosh, maybe 15 years ago on the Middle Harbor project. I was working on that when I was with a company that doesn't exist anymore after leaving the Army Corps of Engineers back in 2002. So look forward to this this discussion.
Yeah, great. The name was definitely looking familiar, and we are a resource to help you with your board. So feel free to reach out. All right, Derek, you are up next, my friend.
Okay. Good morning. My name is Derek, and I'm a PhD student from Memorial University of Newfoundland in Canada. And my supervisor is Bing and Rune. And I'm so happy that I have this chance to take this workshop. And I'm very interested in the dam safety. And my background is related to the environmental risk assessment and the decision makings for the emergency accidents, such as the oil spills. Okay, thank you so much.
Great, thank you. So I think those are our attendees. What we talked about earlier was as we get into the presentations, perhaps we'll have everyone go on mute and turn off their video feed. And then I'll spotlight the speaker. When they're done with their presentation, we open it up for questions and answers. Feel free to turn on your video and your sound. And with that, we will go ahead and kick off. And I'm going to take some liberties here and start off with an introduction. So I'm going to share my screen if I'm able to pull that one off. All right, can everyone see my screen?
Yes.
Culture.
All right, and I have one slide with animation. Those are always problematic, so we'll see if that one actually works out for me today or not. All right, so good morning and greetings from Berkeley, California. I am very excited for today's workshop, and this is a concept I've been working on for a number of years now, based primarily on the work I've been doing related to the Oroville Dam primary spillway failure back in 2017. As part of that effort, I served as a risk management advocate for the local community through the Oroville Dam Comprehensive Needs Assessment Ad Hoc Committee, and that went from about 2018 through 2020. And then later as an expert in litigation things that kind of fell out of that primary spillway failure incident. And I'd say this experience has highlighted a number of things that I'd consider opportunities, and that's leveraging proactive risk management. And it's my sincere belief that proactive risk management is needed now more than ever because, number one, we have a new generation of workers and professionals who don't have all the background and tacit elements of these infrastructures when they were first designed and constructed 50 plus odd years ago. Many of those original assumptions, which are critical to the safety and reliability of the high hazard infrastructures, have been lost. And many owner operators may not even be aware of this important knowledge gap in their systems. And finally, the effects of aging, burnout failures, as well as new loading paradigms associated with the impending climate change have largely been unevaluated. It's my hypothesis here that if we assume that the past is a perfect predictor of the future, we'll be routinely surprised with poor performance. Rather, let us be the stewards of the future and proactively ensure our critical infrastructure systems have the target safety and reliability that we want. So a little bit about me, and I'd say my perspective might be a little bit unique, but it's systems-based and looks at the whole life cycle of the system with consideration for both the physical aspects as well as the human and organizational factors. Today, I'm wearing the hat of Executive Director for UC Berkeley Center for Catastrophic Risk Management, or CCRM. But I also have a consulting practice, a software development company, a construction company, and just recently started a nonprofit on the topic of safety, risk reduction, resilience, and reliability. I have a varied register of disaster research and forensic engineering. My focus includes the human and organizational factors rather than just a focus on the physical aspects of failures. And this disaster research has identified some cross-cutting phenomena related to safety and reliability of critical infrastructure systems. While many industry sectors may differ, they all share one common feature: they're managed by people. So as part of my work on Deepwater Horizon, we've been dealing with issues related to safety culture. The National Academies published a document titled Strengthening the Safety Culture of Offshore Oil and Gas Industry, which I do highly recommend, and I have a link posted on the website for that document. And I think this document does a great job of providing a background on safety culture that's really applicable to any industry, not just offshore oil and gas. The report also presented 9 traits of a positive organizational safety, and I have those listed on the slide here. The idea is, you know, we're always looking to see what could go wrong and being proactive, and that's a shared trait that goes throughout the organizational hierarchy, if you will. So it's embraced at the top levels, implemented at the lower levels, and yeah, everything works great and wonderful and groovy. All right, the animation is working. So the other impactful thing that safety culture report highlighted for me personally where there were 3 different risk management frameworks at play in Deepwater Horizon. You had a regulatory component through the Bureau of Ocean Energy Management, formerly MMS. You had this concept of prevention through people that was embraced by the U.S. Coast Guard as part of their response to the oil spill. And finally, there was another management paradigm, integrity management, that was embraced by PHMSA in their oversight of the pipelines. And the thought that occurred to me was, hey, instead of having these be 3 different distinct elements, why don't we lump them into a larger approach and leverage the strengths of each of them? So if we start off with integrity management, kind of as the base of that triangle, answering questions like, well, what is the infrastructure supposed to do? What makes it reliable? What makes it safe? We then have the ability to communicate those throughout the owner-operator workforce so that the people can be on alert looking for deviations from the expected performance. And then finally, we can use regulation as a check to make sure that we're not repeating any mistakes from the past. So I think this slide for me does a great job of illustrating how I see the practice of risk management currently. There is some perceived threat. Then, because we don't really know the likelihood of that threat manifesting itself, we debate and argue until action is required. So the problem with this approach, especially in these high hazard infrastructures, is that when things go wrong, the consequences are typically catastrophic. So I think what we need to do is acknowledge that this decision-making process exists and build mechanisms to maximize our proactive actions. For example, we know that failure is a time-dependent element, not a static one. And our systems frequently have a high failure rate at inception, known as burn-in failures, followed by a much longer period of time with relatively benign failure rates until we reach the end of the life for the system components and start experiencing burnout failures. And I would argue that an active integrity management program with explicit descriptors of what is safe, what is reliable, would enable active prevention through people to detect and correct those burnout failures, which will become more and more a problem as components built 50 some odd years ago wear out, coupled with dramatic changes in environmental loadings that may occur from climate change. I think it's also important to recognize that there is a very big difference between statistics and probability. Statistics is focused on the past. These are events that have actually occurred. There's empirical data. But probability, on the other hand, is a forward-looking perspective that uses the past as a guide, but also requires judgment to extrapolate occurrences off into the future. Sea level rise, for example, has been extensively modeled to generate predictions for the magnitude of future potential sea level rise. And I think if we use the past data to blindly project into the future, it probably wouldn't be very surprising for us to be surprised later when the water levels are different than what we expected. So that kind of brings us to the workshop that we have today. We're going to lead off. Paul is going to give some background on high reliability organizations. That kind of couples back to the safety culture traits from the offshore oil and gas report. Dell is going to talk to us about challenges looking off into the future. And then we have Jason, Ray, and Bob that are going to speak from an actual owner-operator perspective to share kind of the challenges, the available resources, the wins that they've had. And what I'm trying to do is put together kind of a resource, a positive role model in the space of proactive risk reduction. So if we have other organizations out there that want to follow this path, they've got someone kind of blazing that trail for them. So with that, I will attempt to stop sharing my screen, and I will pass the ball over to Paul.
Are you by any chance seeing what I tried to share?
All right, you're good, yeah. So I'm going to spotlight you, and it's your show.
Okay. So as I mentioned, and some colleagues have been spending a lot of years looking at organizations that had to manage very hazardous technical systems and looking at organizations that did that very well. We selected organizations that were well known and well regarded in terms of their reliability and their safety management. And we spent a lot of time. The shortest amount of time was about 6 months in one organization, a nuclear power plant. A colleague and I later spent looking at the California Independent System Operator. We spent 7 years on and off watching, seeing what they do, and interviewing people until we became a real nuisance. And so I just want to describe, we wrote a number of things describing what we were seeing in these organizations. We didn't necessarily have a theory about reliability and safety. We just wanted to see what it is they do. How do they work? What do they think? And so some of the stuff that we've described, some of the descriptions actually are now part of what people think of as a safety culture. But I want to go in and very briefly, if I can here, give you some descriptions of the kinds of things we've seen. And now we have a little more idea of why it is they're there in successful, relatively successful organizations. So the first thing we saw was they had a pretty clear conception of what reliability and high reliability meant in a couple of dimensions. One is reliability isn't just service reliability. Reliability to them is the reliability of their internal processes. And that also depended on the reliability of their cognitive processes, so they wouldn't make cognitive errors. And as you'll see, a lot of the features that we've seen have to do with that issue of cognitive errors. Obviously, they're interested in the continuous provision of desired outputs, but not to risk safety. In the nuclear power plant, they will shut down operations if they're in what they would call unstudied conditions. And if they see they're out of their precursor zones for various parameters. And pilots, of course, will refuse to take off if they're not satisfied with the condition of their aircraft. One of the best descriptions of safety and reliability that I've ever heard was by a psychologist named Carl Weick, who said that safety is the continuous dynamic production of non-events, things that don't happen. That's different than just an organization that so far hasn't failed. And it's not the same as an interval of time without accidents. The non-events are actually the outcome of lots of dynamic things that go on in the organization to prevent them from happening. These organizations had a fairly distinctive approach to both expertise and error. The continuous and repetitive outputs they're trying to produce with safety rested upon very well understood technologies in most of these organizations. They were not experimental systems. NASA was not and never has been a high reliability organization in the sense that we've seen it elsewhere, because they have been operating with experimental systems for most of their operations. And workflows are based on knowledge that's embedded in formal design principles and models. They have procedures and rules of rightness for operation that they follow very carefully. Procedures in these organizations are not something that nobody pays attention to because they're obsolete. People did take them seriously because they constantly revised and improved procedures, and workers suggested those procedural revisions, and they had a formal process, but a lot of the revisions of the procedures were revised multiple times to correct errors, to fill in things that were incomplete, to take account of different types of systems and changes. And so the interesting thing in these organizations was the people who followed the procedures and had to use them owned them, because they initiated a lot of the revisions. These organizations have an interesting relationship to uncertainty. The limits of knowledge and their uncertainty are constantly acknowledged, and in fact are characterized in the organization. The Nuclear Regulatory Commission even actually has formalized at least 3 types of uncertainty: parametric, which involves the measurement uncertainty. Can we really trust this sensor reading, for example? Do we really believe? In one case, a person in a nuclear power plant didn't want to shut down an instrument error system until he checked personally to make sure that there was no common mode connections between the reactor being overhauled that they were going to shut down the instrument air system on and the other joint reactor that was operating. And I said, well, don't you have documents and measures? He says, I don't trust them. I'm going to walk every inch of it down myself. Modeling uncertainty. Do they actually really understand the way the system is actually worked? Is the model does it capture accurately the characteristics of those systems? And incompleteness uncertainty, unknowns. In many meetings that I attended in nuclear power plants or even in aviation maintenance units, people would ask, have we thought of everything? What are we leaving out? That issue, what are we leaving out, is something they're very interested in trying to think about. So in this way, types of uncertainty are differentiated and specified, and it provides information about potential errors that could happen and the risks they were running. So, you know, uncertainty is its own form of information. So what else did they do? It involves analyzing both probable but also possible chains of error. Yes, they do risk assessments all over the place, but these organizations, because of the catastrophic things that could happen, also have to manage to possibilities at times. And so they spend a lot of time looking at these chains of errors, and that leads them to spend a tremendous amount of time and attention to precursor conditions. They have tried to map out a set of precursor conditions that could lead to errors that would then propagate downstream. Obviously, you know that there are mechanical precursors to things, too much pressure getting out of the normal nomograms for pressure and temperatures. But they also looked at organizational precursors. One of the things that we saw in many cases is noise in the control room. If it's too noisy in the control room, that is a condition they don't want to operate in. And so they will throw people out of the control room if that turns out to be the case. In the inspection of workplaces, tools that are not put back properly. The Institute of Nuclear Power Operators actually looks for that, because they feel that if people are sloppy with their tools, they could be sloppy with other things. Shoelaces untied in rail yards. Well, what does that say about the safety culture of an organization? So amazingly, they look at these precursors and they're actively enlarging the zone of precursors in order to reduce the fluctuation in operations. And as I once formulated, the key to high reliability and safety is not invariance. It's the management of fluctuations, because there will be fluctuations all the time. Lapses of attention, fatigue, complacency. All of those things are things that they try to manage within narrow bandwidths. Precursor conditions, as I say, include organizational conditions as well as physical. And what these organizations develop is what we came to call a precursor resilience. The mindfulness of precursors to quickly recognize when they are entering a zone, and a quick response in order to restore operations to acceptable bandwidths. And in fact, if they're not acceptable in nuclear power and civil aviation, they will shut down the system. So those are important properties that we saw in these organizations. We found interesting structural features. Again, formal procedures. These we found in many settings, and again, they were living documents. Their organizations, their bureaucratic organizations, many of them, they had a chain of command and they had specialized job descriptions and responsibilities. But many work groups were done in teams. There was flexibility in non-routine situations for decisions and responsibilities to migrate downward to those who had knowledge. and we're closer to decision implementation. In a sense, under non-routine situations, it was not unusual for authority to yield to knowledge, which was more likely to be accurate because it was closer to actual real-time conditions, and didn't reflect a problem of lag in communications. And we also found a very interesting personality type. With respect to reliability and safety, many workers functioned informally as what we called reliability and safety professionals. We call them that. They didn't necessarily have degrees, engineering or professional degrees, but they adopted as part of their operation and identity a set of standards for themselves and a set of values about their responsibilities with respect to the system beyond just their job description. Because system errors are the kinds of errors in these organizations that are likely to be most consequential. The need to keep track of the system implications of what you do are really important. And so these reliability professionals, as we call them, first, were always alert to precursor conditions or other things that were important. I was sitting in a nuclear power plant interviewing a chemist, and suddenly he looks up and he says, "What is that noise? I've never heard that noise before." And he runs out and leaves me alone in his office. And 20 minutes later, he comes back. He says, "I'm sorry, I just had to know what that noise was. I hadn't heard it before." Well, that was a precursor condition. The other interesting thing was it has nothing to do with chemistry. It wasn't his job description to worry about noise coming from an area that is not related to boilers and boiler compositions. So he assumed that role. And these people are distributed around in different levels in the organization. And the interesting thing is they are recognized and respected in the organization for those informal roles that they play. Communication patterns, unlike formal organization where communication runs along the hierarchy of authority, these organizations have distributed information systems where people will talk across units, across levels. And the communication process is distributed that way because it helps people to keep track of the system implications of what they may be doing. So that was another interesting feature. Then issues of what are now called safety culture. Widely shared assumptions, attitudes, values, and practices. They internalize a commitment to reliability and safety as part of their personal responsibility, even as part of their identity. That chemist who ran off to find out what the noise was, had, in a sense, to do that, to be the person he wanted to be, to have the identity that he had. And he assumed the responsibility for that, for tracking down what that noise actually was. Responsibility for safety is assumed by everyone, or almost everyone. It isn't offloaded to those designated as safety officers or who work in safety departments. Everybody is a safety officer in an organization that has a high reliability culture, and we've seen that in the organizations that we've been looking at over these years, the good ones. Improvement in reliability and safety is tremendously valued. I would talk to a plant manager once who said, if we're not getting better, we're getting worse. And so they're constantly looking to see if they can get better through revising procedures and refining them, through new technologies, but only after they are carefully analyzed, because a new system, one of the things I used to say was, when a vendor improves a valve, that instantly is an alarm for us, because we have to test it out and make sure that it conforms to the specifications and the predictable behaviors that we're used to. So that's really important for them. Root cause analysis of incidents and accidents was taken so far, it seemed kind of ridiculous to consider whether if he got a good night's sleep the night before, had something to do with an accident that he was involved in the next day. But they got to that degree of consideration of root causes. And again, constantly revising what are considered precursor conditions in order that they can be more sensitive to possible amplitude increases in the bandwidth within which they wanted to operate. The other thing that was clear was simple compliance with regulators was not their definition of safety. Some regulators, unfortunately, think that that is the definition of safety. One of the people I talked to in a nuclear power plant said, you know, we know more than the regulators do. We can't just follow what they say. We have stricter rules than they do because they're behind the curve in terms of understanding what the actual conditions to operate should be. Constant watchfulness at all levels, constant search for possibilities to improve things. Other features of HRO culture, a general commitment to excellence. I noticed that one of the participants today is involved in excellence, and a managerial crispness that can be seen even in areas that lie outside of immediate production processes. You go into one of these organizations that is well managed and you find things work. Things work in restaurants. You don't have stalls that are not working and maybe haven't been for weeks. Food services work, lighting works. So they don't have a backlog of maintenance and even mundane and everyday things because people just haven't gotten around to them. The irony is I walked into a nuclear regulator's building and I find the restroom is always closed. There's, plumbing isn't working. They always have sinks that aren't being used. It conveys a very different idea of what excellence is. And there's a wonderful saying about this. I can't resist saying by a regulatory analyst. He said, if you manage to adequacy and not excellence, then inevitable lapses when they occur will be away from adequacy and not excellence. And that seems to be internalized here in these organizations. People are encouraged, they're not punished for speaking up about concerns. And prompt corrective action processes involve widely different personnel at different levels who identify problems and are rewarded for doing so. Individuals and HROs recognize that there is a possibility of mistakes, unexpected issues, and surprises in plans and decisions, and they always are mindful. I sat in on a briefing by one of the heads of the instrument and control unit in the maintenance department. They had devised a new procedure, and he was talking to his supervisors, and he said, when you go out and you introduce these procedures, don't you for a minute fail to tell people that this technology is still capable of surprising them. So that's a kind of culture that you see in those organizations. Their decision-making involves practices that emphasize prudent choices over those that are just allowable. And a proposed action has to be demonstrated to be safe in order to proceed, rather than putting the burden of proof on somebody if they're concerned about whether it is safe or not. That, unfortunately, was the practice in NASA, which led to the Columbia disaster. So in all of these features, just to conclude, there's kind of a hidden design in them. Many elements that I've described that we saw in structure and culture are there to constitute a strategy for the avoidance of cognitive errors in organizational decisions and actions. These elements reflect an aversion specifically to errors of misperception, misestimation, and misspecification that they believe to be and often are root causes of failures and accidents. They're always questioning assumptions to guard against these kinds of errors. Suppressing these misunderstandings is a foundation, they believe, for high cognitive reliability in managing processes, which in turn is a foundation for safety and reliable outputs. Thanks. There's a glossary of terms, but this is not part of my presentation.
And
yes.
we'll post all these presentations on the web, so if you want to go back and look at them, you have that ability.
Okay, how do I do that? How do I get myself?
I'm going to post them, Paul.
Okay, do it. Thanks.
Yeah, it'll come shortly. So if you have a question, feel free to turn on your video. We can also try the chat. Del, do you have a question for Paul?
No, I was just getting ready to talk. So
Okay.
no, I don't. Sorry, Paul. It was a great presentation. Yeah.
Any questions or comments out there? Paul? Paul, thank you so much for the wonderful presentation. I personally believe that there is a lot of merit in the high reliability organization approach that can be helpful to organizations out there. I think one challenge for us has been communicating this to the various organizations out there in the world. A lot of people have still never heard of high reliability organizations, even though that's been around for what, 30 years?
Yeah, about, yeah.
And so that's one of the motivations why I invited Paul to speak this morning, was just to publicize and make available these existing resources that are out there that might be helpful for people. So thank you so much, Paul. I will now unspotlight you, and I will spotlight Dell as we move on to the next presentation. And the floor is yours. Paul, you need to unshare your screen.
How do I do that?
There should be a stop sharing option somewhere.
I don't see that little, I don't see.
Oh, there we go.
Here it is. Yeah. So I'm gone now, right?
All right. Thank you, Dell. The floor is yours.
Well, thank you, Rune and Paul. Excellent start to the conversation. I've already introduced myself already, so I'll not do it again. But the topic of dam safety is a complex one, and for today's talk, we've just addressed one, and that's looking forward, and is especially in the face of climate change. So. There's much more to talk on this topic of a broader dam safety, but just keep in mind that we're gonna take on one topic today. So my intro slide is the number of dams in the U.S. and as you can see, there's those about 91,000 dots in the U.S. And so how do I forward? Oh, there it is. So a little bit about U.S. dam safety, and actually we'll start with worldwide dam safety. So. There are about 900,000 dams in the world. Of those, about 60,000 are very large dams, and of those 60,000, about 54 have experienced failure of a complete and total failure. Over 200 have partially failed. So if you look at that, it's about 1 in 1100s. Our own history didn't start off very well. We started building dams in earnest. A little over 100 years ago, and we had a very poor success rate of that. About 1 in 22 failed of the 600 dams built early. We got better in the 30s and 40s and 50s as geotechnical engineering and soil mechanics came into vogue. We only knocked down 1 in 350 of those. Really the modern time frame that I consider a modern dam is from 1960 on, and that's when we really started to understand different zonations of embankment dams, geotechnical engineering, all that stuff. Even so, from 1960 to present, of dams over 50 feet tall, which is a fairly subsizable dam, we're still failing about 1 in almost 1,400. Interestingly, if you actually look into the smaller dams, the failure rate, and there are much more smaller dams than there are larger dams in the U.S., the failure rate's about the same. This is a little over 1,400, 1 in 1,400. So it's disturbing, and it's obviously a failure rate that's, in my opinion, far too high. The primary failure rates usually are lumped into 3 major categories: overtopping, foundation and geotech issues, and then seepage and piping. What do I mean by those? Well, it's just one of the first real famous dam failures was in the late 1800s in Johnstown, Pennsylvania, and that was an overtopping failure. And it was the Johnstown flood was created by the failure of the South Fork Dam outside of Pittsburgh. The South Fork Dam was a hunting and fishing retreat for the elite of Pittsburgh, the steel magnates of the area. It wasn't an overly large dam, but 72 feet high is big enough. Interestingly, the low-level outlet, which controls the release of water from the bottom of the reservoir, very important, was abandoned and sold for scrap. And the spillway was blocked by a clogged fish screen that kept the fish in the lake, and so that created a spillway that was undersized and inoperable. The resulting flood killed 2,200 people. Very famous floods. 99 entire families were wiped off the earth. It was just a horrific situation, and the elite of the day were able to wiggle out of the lawsuit. So there is the North Fork Dam, and the spillway was just about right where that breach is, and eroded away. The resulting damage of Johnstown and other communities was very significant, as you can see from some of these photos. So interestingly, really didn't spur on a lot of discussion on dam safety in the area. That had to wait till the St. Francis Dam failure, which is another very famous case study in our world, in California, in Southern California. This was in 1928. The famous William Mulholland, who was a self-taught immigrant engineer from, I think, Scotland or Ireland, one of the Celtic states, designed about a 200-foot high arch gravity concrete dam, very substantial dam. This was part of the Owens Valley water fight. They needed a terminal reservoir down at in Los Angeles to collect all this water and distribute it there. So at first filling, the dam failed. It was filled to its crest on March 7th, and less than a week later, it failed. Right about midnight, in fact. There was quite a bit of debate at the time on the failure, but it was very obvious to me and others that the left abutment was the problem child of that. It killed about 500 itinerant workers who were mainly camped along the river. There is the St. Francis Dam, and this is a classic geotech failure. You can see on the left abutment there on the right of your screen. We always talk about left and right looking downstream, so just as a note there, but you can see what are quite clearly the telltale signs of a headscarp of a landslide. And there's a better view of those slides on the left side. As the reservoir filled, it destabilized an ancient landslide on the left side of the abutment, and the whole left side of that hillside came down. So that's a geotechnical type failure. The last type of failure is a seepage and piping failure. There's the most famous case of that in the U.S. is the Teton Dam in 1976. Interestingly, this is the Bureau of Reclamation, which was considered at the time the preeminent organization for dam design and construction. Designed and built this dam. Where they really fell apart, though, is that they had two separate groups. They had a design group and a construction group, and the two hated each other. Neither one was going to tell the other how to do their job. Famously, the designers never went out to the construction site. They just created their plans and specs and turned them over to the construction guys, and the construction guys built the dam. As it happens on these jobs, they encountered a condition on the right abutment this time that was different from the expectation of the designers. The designers refused to go to the site. They said, "Build it as we've designed," and so that's what they did. They placed fine-grained clay into open joints and cracks and fissures on the right abutment, and soon as soon as they started filling it, all that material washed out through the right abutment. There are some famous geotechnical engineers at the time, Terzaghi, Peck, others, felt that there might have been a low density issue. I dismiss that opinion. It's you just don't place fine-grained soils into cracks and expect it to stay. So there's the dam near at completion. The rapidness of the filling also contributed to the problem. It also had no working outlet. The outlet was not completed at the time, and so they didn't have any ability to remove any water during the filling. That's the seepage they noted the night before the failure. It's a pretty safe assumption to say that at this point the dam has failed. Although heroic efforts were done, what they really should have been doing was evacuating downstream. That amount of seepage and flow through the right abutment is quite significant. It's very muddy. It's moving material. Here's the propagation of that seepage up that right abutment. If you can see, I don't know if you can see my cursor right here. That's a bulldozer And that man is a very dumb man. He was lucky he wasn't killed. He's attempting to walk his bulldozer down the face of that dam, a 300-foot high dam, and infill this rapidly expanding hole in the dam. The large cavities have already formed, and everybody should have been running and evacuating. But that really speaks to the lack of understanding of the system and the dam and how it works and what was going on. There's the full breach. It killed a dozen people, one by suicide actually, who thought he was going to die anyway. So real quite tragic actually. That's an internal seepage and piping failure. So, but again, what are we talking about here in the U.S.? Well, there's 91,000 dams. The vast majority of these are under 50 feet in height. I think there's only 5,500 of those 91,000 that are over 50 feet. So primarily we're talking about smaller dams. What are they? Who are they owned by? These smaller dams are primarily owned by private owners, mostly irrigation or small recreation ponds, things of that nature. A good deal are owned by local governments. This is primarily water supply. The public utility is all hydropower. The state is typically water supply. And then the federal is a mix. Those are primarily irrigation in the west, in the Mississippi Valley and the Ohio River. That's navigation primarily. And so those are the mixtures. Those are also many of the big dams that we have. These are all typically regulated by the state, with the exception of the federal dams. Interestingly, one state, Alabama, has no dam safety regulations. And it's no surprise that there's a massive lawsuit going on related to the construction of a new dam in Cullman, Alabama, right now, where I worked on a project there. So I find that actually unacceptable. We've been working on Alabama to get up to speed and have a dam safety program at the state level for a long time, and they continue to refuse. This is what I was alluding to earlier. Really, the history of dam building in the U.S. Was plodding along, but in the post-war years of the 50s and the 60s and then less into the 70s, that 30 years is really when dam construction was at its heyday in the U.S. And so, and again, I consider these modern dams. They're typically well designed and well constructed. Since then, though, we've stopped really building dams. From 1990 on, new dam building is very low, but these dams still exist, and they're being maintained by generations of engineers who had no involvement in their planning or understanding the nuances of these things. Documentation is often very poor, and so the cadre of engineers worrying about these things are generations separated from those who designed and built these structures. And so it's a real significant challenge. Again, this is what I was talking to earlier as well. The majority of dams in the U.S. are under 50 feet tall. I would say that's the majority of dams I work on. The big ones, the real big ones, are quite a minority, only 5,500 of those. When we look at a dam and worry about its hazard potential, we're always talking about loss of life. And so when you see a high hazard dam, what we really mean by that is if it failed, will it kill somebody, or does it have the potential to kill somebody? So currently, only about 14% because of the height, again, are considered high hazard dams. However, that's starting to change as we go into as we expand and grow into once rural areas. We have now urbanified, I guess, to make up a word, these once rural areas, and these dams that were sitting there all on their own, where all of a sudden have a big housing development at the downstream toe. That's its own problem, because a high hazard dam is treated differently in our world than a low hazard dam. You need a larger spillway, you need emergency action plans, you need a whole host of other things that you typically don't need for a low hazard dam. So this number is creeping up, and will continue to creep up as we move. Back to my earlier comment about the age of the dams, when I started working on these back in the late 90s, mid 90s, it was dam engineering and dam safety was a pretty sleepy little part of the civil engineering community. The combined aggregate revenue of the firms working in those, and this is Engineer News Record data. They track a variety of markets. So if you add up all the engineering revenues as reported in the ENR each year, back in 1997 or 8, that was about $100 million US. At 2005, I began to notice that we were getting a lot busier, and I started wondering, well, what's going on? In 2010, I wrote a paper because it got to the point of ridiculousness how busy we all of a sudden were. We went from begging for work to not being able to do it all. And so I started looking into this ENR data a little deeper, and we went from 100 million to about 800 million a year in revenues in just a span of a little over 10 years. And it was outstripping our ability to do the work. You can hypothesize a number of reasons why that. The inflection point is right around here in 2005. I think it was Katrina. Tom Sock Dam also failed in that era, so that spooked a lot of folks. But I made the bold prediction at that time, and I thought, well, I think on the upper end it'll grow 8%, on the lower end it'll grow 3%. Somewhere in this cone is where we will be, and a lot of people scoffed at that. The reality has been not 8% turned out to be a little ambitious, but we're just a little over 5% annual growth from that time. So our sleepy little part of the world that did $100 million in the 90s is now up over $1 billion. We've added a zero, an order of magnitude onto our engineering revenues. And to be blunt, it's just outstripping our ability to do all the work. We're now at 1.3 billion. By 2025 to 2030, we're probably close to 2 billion in annual revenues for engineering firms. So there's a reason for that, and the dams are, as I mentioned earlier, about 60 years old, and they're not getting younger. They're continuing to get old, and we're reaching near crisis state actually. So it's a long introduction to looking at just one element of dam safety, but in the in my hometown or home state of Colorado, we have been using the NOAA hydrometeorological records to estimate extreme precipitation events. And again, if you go back to my comments about spillway sizes, a high hazard dam needs to be designed for the PMP event, the probable maximum precipitation event, and the resulting flood of that event. The best data that we had were the HMR records from the 70s that NOAA prepared. In the 1970s, they simply stopped supporting that. Those were really their best guesses. They still collected the data, they just didn't do anything with it. And so we had these HMRs, and we would estimate the floods, and they were always wrong. So just a few years ago, I want to say in 2018, Colorado and New Mexico, which were geographically similar, said, well, we just need to do our own. And so they picked up the mantle of this exercise, and they needed a new PMP estimate. It is not a probabilistic, it is deterministic, but it also talks about probabilistic methods. So how has this gone about? So, again, there's no real explicit consideration of climate change to any of the previous US PMP studies because they simply were too old. They were in the 70s. And so Colorado, thinking, well, we're getting warmer, and the data certainly supports that, began picking this up. So how did we do that? Well, Rune, you started us off by, well, we could look backwards to look forward. So we did collect some data, and it went back to the 50s. About the 80s and 90s, we noticed a warming trend, and so as engineers and scientists do, they plugged that into the model, and they said, well, we've got all these ranges of potential temperatures. They settled on an observed trend of about 2 degrees Fahrenheit in roughly 40 to 50 years. And so they kind of coalesced around that idea. And then they looked at the Clausius-Clapeyron equation, which is a pretty basic equation. It just says as your atmosphere gets warmer, it has more potential to hold moisture. and it's very well documented. There's the curve on the left, and then here's your observed data on the right, and that's your relative humidity of 100% boundary. So as you get warmer, you can hold more. The atmosphere can hold more water, and it's a really straightforward relationship of about 3.5 degrees per 3.5 degrees Fahrenheit per 1 degree. So so 2 degrees plus times 3.5 is 7 degrees. That was one area of data that was that there was a pretty high confidence that we could look at. What's less certain are all the other things that go into modeling storm events and extreme rainfall events. You know, convection, storm efficiency, duration, tracks, precipitation type. You're like, can't really get our heads around that as well. So they coalesced around this one idea of 2 degrees, 3.5% of moisture per degree. All right, let's just design our spillways for 7% for the next 50 years for a 7% increase in the extremities of a storm. And that's really about as basic as it gets as far as looking into the future. So the actual rules of the Colorado Dam Safety Office were altered 2 years ago, and there's now an atmospheric moisture factor, and there's that 7% right there, 1.07 for the next 50 years. We expect the intensity of storms and the resulting size of the spillway to pass those storms will increase by about 7% because of that 2 degree Fahrenheit warming. There is a nice end to this story. NOAA has received almost $500 million from the recently passed IIJA study, and they are going to relook at extreme precipitation events and also provide some additional guidance on this topic. So that's again just one area. There are many others that we need to address, but on the storm front, we really need to look at similar studies regionally and factor those into our spillway designs, our hydraulic modeling, all of those things. With that, I will thank you for your time and ask if there are any questions.
Great, thank you, Del. I'm going to take liberties and start off with a question while others, and again, feel free to post questions in the chat or raise your hand or video yourself. Del, you talked about the changes in the probable maximum precipitation, which ultimately impacts the amount of water that's being released from a dam. You also talked about the urbanization of some of these downstream communities from the dams. If we look at kind of the emergency response, is there coordination between the communities and these dam owner operators when it comes to, we'll call them elevated releases from the dam? So if there's some large event that happens and they have to release more water than the community has been privy to, most communities I don't think have been configured to accommodate the worst case scenario, the probable maximum flood. They probably are accustomed to a much smaller, like 10% or 20%. What are your thoughts on that kind of challenge? Because that goes to not necessarily the safety of the particular dam, but it goes to the safety of the community that's living downstream. And how do we address those more social elements of these dam systems as we venture off into the climate change terrain?
So in Colorado, each high hazard dam is required to have what's called an emergency action plan. And that emergency action plan is required and has all the data, all the phone numbers, all the events, typically 4 or 5 levels of emergency and associated responses. Not every high hazard dam does have what an EAP, emergency action plan. I think the majority do, though, 85%. So we're slowly getting those in place. They do not typically have a scale on them. It's either leave or stay. And like, hey, nobody says, hey, there's going to be some water running down your creek. It's either, get ready to go or go. And the go part is typically when there's a big failure. If the spillway is operating and there's more water than usual flowing down the creek, nobody cares. Typically, that spillway is it's doing what it's done. There's a case where in Boulder where 2 people downstream of a dam were killed in the 2013 floods. But everybody, the dam, the spillway was going like nuts, and so 2 people were killed downstream of that. So it's typically been related to loss of the dam and the related loss of life in historically, but not a sliding scale, as it were.
Yeah, and I think that highlights this challenge we have of these dams being larger systems, right? And so the dam owner operator may draw the line at the downstream end of their dam, but actually the releases that they send down the river do have an impact to the downstream folks. And at least in my work with Oroville, that seems to be a communication channel that hasn't been established, is to make sure that we've got continuity between what happens at the dam footprint and the downstream community, so that everyone understands what their obligations are during various storm events. So
yeah, you're absolutely correct. Yeah, you're absolutely correct. Right?
Tony.
Yeah, thank you, Dill. I had a question. In California, the Division of Safety of Dams.
DSOD, yeah. DSOD.
Yeah, DSOD added a 4th category, extremely high hazard dams. And I'm curious if you know of any other state that has done that, gone above and beyond the FEMA hazard classification.
No, I have not. California is one of the first states to actually have a dam safety program, which was formed out of in the ruins of St. Francis. So, no, I'm not aware of other states that have taken up something to extremely high hazards. So,
another follow-up question. We just finished our EAP. We actually had one in place, and then after Oroville, we had to do it over to look at not only dam failure, but spillway failure. And I'm curious, does Colorado's EAP requirements include those 2 scenarios?
No, they don't. And obviously, the spillway failure is a result of the Oroville incident. Just about every major dam owner is just got extremely spooked after Oroville and is looking at their spillway. We're working on one in Michigan right now called Hardy Dam. Same sort of situation. It's a very unstable structure, and we're in the middle of repairing it. No, the spillways are typically treated, well, if they're integrated into the dam, then they're part of the dam. In the case of Oroville, they were sort of integrated into the dam, but the emergency spillway off to the right was a complicating factor, and so it's really a case by case issue, I guess.
Thank you.
Any other questions or comments out there?
If I could, I asked a question that probably shows primarily my ignorance of this, but in some ways, I'm contrasting what you're describing with respect to the dams to what goes on in these other organizations that I've seen. And that relates to the question of precursors. It almost looks like the dam just sits there until it fails. And that makes it hard for people to pay attention in many respects. But I'm just wondering how good could you make the science of precursors so that mainly on a daily basis, people would have to go and check out, look for various things. I mean, like in earthquakes, maybe we can't predict very much, but we can get sort of conditioned. We can learn about them and find more precursor conditions. Is it possible to imagine that you could think about models, because many of these dams, the old ones, okay, they're getting old, okay? Maybe there's a dynamic associated with getting old that makes it possible to say, here are precursors, you got to look every day for signs of X, Y, and Z, and you got to inspect, that would keep people who are managing the dams and regulating them sort of more on their toes, in the same way that their nuclear power people are saying this is a dynamic process, to keep them safe, that might convey a different sort of management style to dams.
That's an excellent question, Paul. They are very static structures. They just, as you pointed out, just sit there, and much of their deterioration is unseen. And many of these dams are in very, very difficult areas of access. I know of dams that it's a 3-mile drive in over rough roads, and somebody cracks a gate and then drives back down. So the time required to get to these structures is intensive. So it's a little less straightforward than having somebody at the site every time. A good deal of the 2,500 dams in Colorado are unmanned and not near anything. And so you're talking about a substantial increase in manpower. Not that shouldn't happen, but the systems in place to make that happen don't exist right now.
Thank you.
Yeah, no problem. Mark.
Yes, I have a question about that issue. And are there technologies that are reliable that would allow standoff sensing and the, you might say, indications of failure that would be signaled via some technology, be it lasers or other means that might help address that issue of remoteness and difficulty in doing frequent monitoring and inspections?
Yeah, of course. There's something called INSAR, which is a satellite-based technology that scans from space and looks for alterations in your structure. That's being promoted heavily by the instrumentation folks. My standard response to that is, that's excellent. I really want to know what's going on inside the dam. Actually, that's where most of my concern is. And so there are other technologies, instrumentation technologies that exist. Bentley, if you know of them, the massive, I think they're 5,000 people. They bought 15 companies in the last year. I just found this out a couple of days ago, all instrumentation companies, and they're making a big push into the market to instrument the world, including dams. And so those are all cloud-based. You need a lot of infrastructure for those. You need either landlines for communication or cell phones or repeaters. There's a lot that goes into that, but it's just expensive and just takes time. You got to drill and install the instruments into the dam and then monitor them frequently. We're working on it. It's just slow, but yes, that exists.
Thank you.
Any other questions or comments out there? I will note, and we'll see how Dell reacts to this. It appears that many of these, especially the older systems, don't have any of the design documentation. So we don't actually know what the original assumptions were from an operational standpoint. So there is the ability, and this would kind of be the leading indicator or the proactive things, is to go back through the documentation. And if you're finding that there isn't any, to do some back calculation or get some understanding on what's the anticipated performance of these structures, so you're not surprised when whatever rain event comes, or if the rebar corrodes and your abutment falls apart or whatever. So just because there isn't documentation doesn't mean you can't go back and kind of recreate something that you can use as an operational guide for that structure. And then also incorporating in notions of life cycle, right? I mean, these things aren't going to last forever. So is that dam embankment going to be there for 100 years or 500 years or 10 years? And putting some serviceable life durations to these things so that you can put together a meaningful capital, investment program and replace things before they break as opposed to afterwards.
Absolutely, Rune. I would say prior to about 1950s to 60s, the existing information is of limited value. Boring logs were not standardized at the time, not until Tashagi and Casa Grande and Peck and all that. So they would just be some person's description. And in one boring log I recall in Oregon, it was looks like quicksand, I think was the note on the drawing. So what do you do with that, right? This is a dam owned by a power company, and go back through there and like, well, we got quicksand in our dam. I don't know what to do with that. So There's also a pushback on drilling through dams. There's a movement within FERC right now of first do no harm. So they are reluctant to allow drilling into existing dams, especially the core, because they don't want to damage the structure. And so, you know, how do you do that? How do you convince FERC to let you go into a dam and take some samples? It's quite complicated, actually.
Great. If there aren't any other questions, thank you so much for the wonderful presentation, Del. And we will move over to perspectives from our owner operators.
And Rune, I have to get down a plane, so thank you all.
Yeah.
Nice to meet you, everybody. Hope we can stay in touch and continue to talk about this. So take care, all.
Thanks, Del. I think we're missing our first speaker, Jason from Santee Cooper. So we will move on to Ray from Duke Energy. Are you ready to rock and roll, Ray?
I am.
Awesome.
Camera too.
Let me know if you're having issues with the screen sharing. There we go. I see it on my end.
See on your end?
Yep.
Let me turn it on. Yeah. Let's see.
The F5 key sometimes works, or we can just advance through them. You don't have to be in presentation mode if you don't want to.
Okay.
We're a flexible group.
All right. It was working earlier. All right. We'll just advance through then. All right. Well, appreciate it, Rune, for this opportunity to share the things that we do at Duke Energy. Some of you may know a lot about our company. My plan today is to basically describe our territory and give you an overview of the number of hydro-related assets that we manage. Then we'll move into discussion on the operational excellence program that we have established at Duke Energy. Paul alluded to a lot of the high reliability organization aspects of it, and that's where a lot of it's tied to. Another part is that I'm going to finally finish up on how we're progressing, you know, with actual data that we've been tracking over the years of the improvements we've been seeing, and then finally we're going to discuss a little bit of an event that happened a few years back, and one of the things that we've done to kind of help close the gap so that those type of things doesn't happen going forward. As you can see from this map, the bulk of Duke Energy's hydroelectric projects spans across North and South Carolina, with the exception of the one up in Indiana. There are about 25 conventional stations and 2 pump storage operating stations. This amounts to about roughly 3,500 megawatts of installed capacity. Back to Del's message there is that our oldest dam is probably close to 110 years old, and that's where one of our plants are located. In addition, our newest plant is about 30 years old. It was probably commissioned in 1991 is about the time frame. So that's probably the newest plant that we have, and the knowledge base that goes with 100 years of technology is they're about gone. we're losing that information, and a lot of it that were established back then, the written down words of how the design basis of those dams and structures and equipment were never really done properly. And it's just of recent that we've been more diligent about putting stuff together. In addition to generating assets, we manage 48 dams and dikes across the region, along with 60 public recreational areas. What I mean by recreational areas is that these are places that we open up to the public for boat access. They can have picnic areas, beaches, and parks. So we're talking about, when you throw all that stuff that we manage as an organization, we have roughly 25,000 square feet or square miles of territory, and that's not what we're counting up in Indiana. So there's a lot of stuff that we do. And one of the things that Duke Energy's commitment is to our customers to provide a well-balanced, diverse fuel mix. And this is one of our key attributes that we have as a company. We have over 49 gigawatts of regulated generating capacity, but from the hydroelectric portfolio, that accounts for roughly 7%. When you think about Duke Energy as a whole, you hear a lot of words that we've got a lot of people dedicated to keeping the infrastructure intact, but the 7% is not a very large number. When you look at the bigger picture, most of the resources are not really in the hydro assets. They're really, from my last count, I mean, I went to our organization chart and we have roughly 226 employees maintaining these facilities. And when you think about what we do as an organization, our team wears a lot of different hats. Our core business, yes, is to make electricity for our customers. But to make that electricity, there are several activities we have to do. The equipment must be maintained and repaired whenever necessary. And that's part of the capital improvement plans. Because again, remember, our oldest plant is over 110 years old and our newest plant is about 30 years old. So there's a lot of work that has to be done, even on the structure of the dams, the equipment themselves. And these components are really large and dangerous. We're dealing at high voltage, and they can cause extreme injury or even fatalities. So we need to take precautions so that our employees can go home to see their families safe and sound each day. And the information on how these equipment operate, again, is all about, we didn't have a good rigor in the past of documenting how things were done, and that knowledge is being lost, especially as that 226 employees, we are expected to lose probably close to 25% of those individuals through normal retirement and so forth. So it is critical that we look at what we have and how we proceed forward. Now the dams, the spillways, and floodgates also need to be inspected on a routine basis. Dale alluded to some of the things that we do is that we do walk our dams every day. Our technicians look for those anomalies per se. We have monitored wells in some of our dams where we watch seepage to understand how the dams are eroding away, and to be anticipatory of things that we need to do to protect our assets. Our team, so just remember, when Mother Nature hits at these facilities, floodwaters can be very unforgiving. And that's kind of allude to the point of what Rune said was Orville Dam. I mean, at the spillway. And that's what our team does, is to make sure our infrastructure are intact so that we're prepared to manage those type of floodwaters that you see that they saw at Feather River. So we're always want to make sure that the work and the infrastructure that we have is continuing to be available to generate electricity for our customers. And finally, while we use the lakes and river system to help power our plants, we need to make sure we keep to the point where nature, with these resources we share with the public, and we have an opportunity to promote and to retain, because we need to retain the control of the waterways so that we can use it for our infrastructures. So how do we manage that? Manage, operate, oversee all these activities at our regions. Remember, we only have 226 employees in our department. Yes, contractors are there. We do have some, but they're not a real viable solution, because the knowledge that they learn from our facilities leave the door, and we need to retain that information so that we can continue to exist within our organization, that these equipment can be maintained accordingly. So as a company, we adopted the operational excellence performance model. This is the cornerstone for delivering on our safety, environmental, operational, and financial goals. We get there through increased organizational capabilities, risk awareness, governance, and oversight, accountability, and lots of employee engagement. These are the things that Rune has kind of described in his objective of this workshop. What we find is that if we focus on expectation through continuous improvement, on operational processes and the culture of our organization, we can get the event-free operation, we can get the optimized reliability and sustained efficiency. So the operational model you see here on my slide is it can be pictured as a pyramid, where we have accountability as the base, supporting the management system, employee enablement, and continuous improvement. These steps are necessary so that we can achieve operational excellence, which is the combinations of the discipline and the results. So accountability. This is where we have the commitment, of everyone to meet the operational discipline, adhere to our standards, maintain consistent performance, and always seek feedback is what we always do. And this is tied to, if you have ever heard some terminology, there is a plan, do, check, adjust model, and the accountability is kind of tailored from that, where you have step one, which is plan. All leaders and employees need to understand what they're doing and what needs to be achieved when they do work in our facilities. It's important that everyone involved has a clear vision of what is expected. And that's the goal here, is the clarity. Step two is the do. I mean, this is where communication and coaching is everyone's responsibility. All employees are expected to communicate with each other and to coach their peers. And also the expectation is that they can coach their management and anyone on their facilities. By doing this, we take that feedback with integrity and respect toward each other, so we can accept the coaching, because we're all here to learn and be successful, and also to watch each other during these evolutions. And next, step three is all about checking. So checking is the way we have to monitor and measure results and outcomes from both behavior and the end result. In other words, we need to know whether we have achieved the behavior changes in addition to the goals and targets that we set to get. And finally, adjust. This is the key part here, is that adjust. Effective execution is always about reassessing the work or the project. So most of our jobs, we have a post-job critique, where we sit together as a team that has done the work, and we talk about what happened and how they can do the job better and make those recommendations. This is all about where the opportunity is to become better. You don't know, the assumptions may have changed from when we originally planned it, or maybe the measurements that we're using weren't revealing an underlying issue. So therefore, the adjustment period when we do our post-job critique is always important. Next, management system. This describes the leadership's key principles and observable behaviors that support and align to our company's visions. This is where this is the opportunity where essentially all the fundamentals of what we do as an organization, how we translate from the leaders of our company to the individuals performing the work, how that aligns in that vision. They use that information to help educate and coach others so that we can be aligned and having a highly effective team and performing actions. Next is all about the employee enablement. This is about the workforce. They're the greatest asset, and enabling them to do the work successfully is key. We train them on the proper tools so they are empowered to have the ownership and involvement in decision making. They proactively reach across boundaries to succeed as a unified fleet so that they can have open dialogue to ensure understanding, learning, alignment, and execution. So this is all about how we set our employees to be successful. We have our human performance tools, our training programs, recognitions, how we engage our workforce, and then the communication styles. We make sure that a lot of these are tied together. And the last piece of this is that our continuous improvement. This is the program, and Paul alluded to, is about doing those type of root causes, how we learn from root causes, what causes people to have incidents. And continuous improvement, or that essentially people are fallible, and even the best people make mistakes. Error is universal, and no one is immune, regardless of age, experience, or educational level. It's human nature to be imprecise. Consequently, errors will happen. No matter how much counseling or training or motivation you can alter a person's fallibility. Unlike a machine that is precise every single time, people are imprecise, especially in certain situations. Events can be avoided through understanding of the reason why mistakes occur, and application of lessons learned from the past events can help. And that's where, as Paul alluded to, the root causes to study of what happened. And then you get the opportunity of getting engagement because people, our team are willing to learn, and they are more open as we investigate and find opportunities to improve. Another piece of it is observations. We have an observation program where our employees are empowered to go watch their peers or management do work and provide feedback. This is a work monitoring process that looks at behavior, identify potential trends that could be rearing its head out, and provide related feedback to workers, management to reinforce those opportunities to be better. And it also gives an opportunity to recognize individuals doing superior activities. So why are we doing this? I mean, why did we implement this operational excellence model? Because remember, people do what they want to do from the past. They said, this is how we always done. Is that institutional knowledge that's been put in place, but our business is changing. And we can't simply be just a regular power generation utility anymore. There's a lot of factors that influence how we do business. From all these external factors, we need to transform our business to be something better. And one step in doing so, we streamline how we produce power. We can operate safer, be more efficient in consistency, and cost effective. And that's where the operational excellence model has helped us to operate safer, we're more consistent on our activities. And by doing that, the cost effectiveness is there. That's why we can have less people. I mean, obviously you can put more resources at a problem, and then you might end up the same place where you started. Therefore, it's important to learn from previous events and establish best practices, which is the basis for our operational excellence program. Now, for us at Duke Energy, operational excellence framework has been in place for about 8 years. Our organization sees huge improvements. So what I'm showing up here is our event-free measures that we've been tracking. You can see probably back in 2015, we had some incidents. We had people getting hurt. What I mean by lockout tagout events, remember, we're dealing with high energy, which is electrical voltage, or even the sheer volume of water that could happen, that sheer force that could hurt somebody. So there's a lockout tag, we call lockout tagout events, where we didn't follow our process effectively, and we had an event where somebody could have gotten hurt at that situation. And then we had environmental events. This is where we are stewards of our environment. We are so close to the water that if we spill some type of petroleum-based product into the waters, is a negative effect to the environment. We've been really sensitive to this kind of after an incident we had at one of our coal sites where we had an ash spill. So we were very sensitive to any impact to our natural resources, especially to the waters of the U.S. So as you can see, 2015, we had a number of them. And as we implemented this model, our numbers slowly climbed down. Still has our safety events, still has some environmental events, but that number is slowly coming down until today. Well, this past year, we haven't had an environmental event. We had one minor lockout tag event and one recordable safety event. And this year, so far, in 2022, we have 0. We haven't had incidents. Now, that being said, I want to say that Paul alluded to this, complacency can start creeping up here. We are now trending precursors, which is the smaller, I'll call them minor events like first aid events, soft tissue events where, yes, no one truly got hurt. Maybe it was a cut, but we're trending that because that's the next opportunity where that would lead to an actual recordable event where somebody actually really did get hurt. So those are precursors that we're looking at right now and studying so that, yes, our numbers are going down, but we're starting to see a little bit of an uptick in that area. Another measure we look at is our force outage. This is where these are outages that happen in our facilities that, yes, our units weren't available to generate when we need them to, because it was either whether it be equipment related, human performance related, or other issues that cause us to be in a force outage. So we track these things to see how we are doing. And again, you can see our rate was pretty high early on in 2015, and it's been steadily coming down. There's a couple of times where we did have a few more extended outages in 2020, but in general, it's been trending downward. And now we're pretty close to where we are. Last year we finished up, it was probably one of our better years, and this year we're actually trending to be much better than that this year. So the operational excellence model is there and has been paying us dividends year after year. Again, you got to remember, if you apply the principles here about being better, learning, and this is all common sense. Nothing's magical here. This is all applying common sense, and we are getting better. And finally, I have a case study here, which this is an event that happened a few years back. I want you to help me kind of review through it and think about what I said earlier and how we could have done better. So back in April of 2018, we had a team of hydro civil technicians, and their job was to remove debris around a spillway. As they were doing this, the outboard motor on the boat, the workboat they were working on, suddenly stopped. It stopped running. This failure allowed the workboat to slowly drift toward the spillway with no means of stopping. It kept on drifting, and employees on the boat were forced to abandon ship before it went over the spillway. And it did go over, and it fell about 40 feet into the toe of the dam. So what are your thoughts that we could have done differently here? Just give some, as we went through as a team, went through and investigated this. We discovered the pre-launch checklist that they used before they went on the task was the only requirement they were held to was based on the U.S. Coast Guard. All they needed was a fire extinguisher, a horn, a personal flotation device, and a buoy ring. There's nothing said that they need some ways of stopping the boat, like maybe an anchor, or maybe some other means of propelling that workboat around, like an oar or so forth. Nope. So we went back and said that our pre-launch checklist should be modified to say certain things like this. It just made common sense. And then the job about debris removal. Maybe we should have done a little bit better where we shouldn't have the water elevation high enough that it started spilling over the spillway. Maybe it should be lower so that the water is calm, and so that the boat wouldn't have a tendency to migrate that way and over the spillway. So then operationally, we could have controlled that. Things like this is just opportunities where we study the event and learn from what we could have done better. We're getting better. We're slowly seeing improvement across our fleet. It's all about our teammates being engaged and identifying these for us. But our journey is not there. We need to fight the complacency. We need to pay attention, especially to the human performance piece of it, where that's now trending up a little bit, where people are getting too complacent and slipping a little. But I'm going to wrap up right there and open up for some questions.
Great. Thank you, Ray. That was super informative and nicely illustrated some of the things that we were talking about earlier. Tony.
Yeah, thank you, Ray. Great presentation. I originally got my PE license in North Carolina, so I know a lot about Duke Energy. I had a question. When you're recruiting new staff, does this come up during the hiring process, like trying to see if the candidate would fit into this model? And then secondly, once you hire somebody, is there like a immersion into this training and into understanding this model? How is that implemented for a new hire?
So a new hire, that usually it's hard to find people that knows anything about hydro assets and how to work around dams in the facility like this. So that's one piece. It's the technical piece. And then the other piece is that we do have human performance training where we educate them on these various tools. And I mentioned some of them where you have your basic STAR method, where you stop, review, act before you act, and so forth. So those type of human performance tools are taught we do have requirements of doing a pre-job brief training where they need to understand how to have a meeting before they start work or a task. So things like that, they need to have experience, and it's never a challenge for them to learn these things because a lot of this stuff is pretty common sense, right? It makes sense. Let's have a discussion before we start work, and the challenge is the teachable moment is how can they recognize the risk of doing that job? Say, for instance, changing a light bulb. What's the risk of climbing a ladder and changing a light bulb? You think, oh, no big deal, right? I do it all the time at home. But we actually had an incident where somebody slipped climbing a ladder to change a light bulb. And it wasn't even a tall ladder. It was maybe a 6-foot step ladder. So that's the challenge of when you hire somebody new, you got to emphasize the fact that, yes, you can do the job technically, but you got to look out for yourself and for your peer because they're looking after you too. And that's the real big thing.
Yeah, thank you very much.
Just a quick comment on the boat that went down the spillway. In a number of organizations I've looked at, they would have a work planning process and they would think about what's the worst thing that could happen, and that would have been something that they would have said. And then if you think about also, they were in what they would call an N-1 condition with respect to their worst event. If the boat motor fails, apparently the boat is going through the spillway. It's not, there was water flow, it would have taken the boat there. So you don't want to be in an N-1 situation with respect to the worst case scenario. And that would have been kind of a process that people would normally do in a work planning thing. That would be part of their work planning function.
Yes, Paul, that you are correct. Back then in 2018, we didn't have that foresight to think about what's the worst thing they could do because they clean debris all the time. This is a normal work activity. You go out there with your work boat, you pick up debris or you cut with debris with a chainsaw. That all happens on a normal work day, and they use a lot of their personal experience in doing that. Now, what things like this highlight the fact that we weren't thinking like that. And our work planning didn't even consider, oh, that motor could fail and that's what's going to happen. We're going over the spillway. So the lessons learned is that we now are being more eyes wide open now to see that this could happen. Anything could happen. You can't put up those blinders like that anymore. And we have those discussions. And in our pre-job brief, there is a section that asks the specific question, what's the worst thing that could happen? And they're being challenged to ask that question. And it's not the work leader that says it. They want the employees, they're together to have that discussion and make those aha moments together as they go through that checklist.
Thank you. Yeah.
Any other questions or comments? The floor is open. There's always a lag when we do the virtual stuff as people hesitate to either raise their hand or put the question in the chat box.
I understand. Yeah, it takes a little bit.
And we'll cycle back after the next presentation as well and kind of open it up as a open discussion forum. Not seeing anyone else turn on their video feed or raising their hand. Thank you again so much, Ray. Very insightful. And hopefully you will continue to stay engaged as one of these positive role models. I'm sure there are a lot of other organizations out there that would have questions on implementation. How does it work? And so part of the intent here is for us to kind of form this working group to make resources available for these other organizations to help them down this path.
Yeah, and I'll admit that it was a rough start. And the challenge is to get we do have a lot of seasoned individuals that's always used to doing a certain way all the time, and it may not be the best way of doing things. And you have to overcome that barrier as you learn from those things.
Yeah, great. Thank you. Okay, we will move on to Bob. Were you able to, I don't think you sent me your presentation, right? So you have it locally? You're on mute. See if I can, I don't know if I can unmute you.
Yep.
There we
Can
go.
you hear me now?
All right,
Okay.
yes.
You have a visual as well. I think we solved that camera issue.
Oh, good.
So let me share the screen here. Yeah, I could not get that presentation to you, so we'll have to work on that. I don't know if you can see my screen there.
Yep, you're good to go. Looks great.
All right, I think that's presentation mode there. So yeah, very, very good discussion. I really appreciate the other presenters here, really informative. And I think you'll see some duplication in this presentation as well. Yeah, I gave you a brief background of me, but today I was just going to give you some more background on the Power Authority and something called the Canal Corporation, which you may have heard of the Erie Canal, and that has evolved into the Canal Corporation. And I was going to go through our safety culture here at the Power Authority, a brief review of our dam safety program and an independent audit that was done. And really our challenge is to instill this culture in operation. So that's our current role. We took over in 2017. There was an act of legislature, and I think it was because the Power Authority has dealt with large infrastructure for some time. They thought there was some synergy there. So once we took them over, there was a review of their assets and identifying, prioritizing the risks. So I'll give you some of the progress we've made to date on that front, as well as looking ahead, some of the challenges that we're facing. So just a brief background on the Power Authority. This is the state of New York. These lines here show that we really have a lot of the backbone, high voltage transmission. We connect to Canada on several fronts, over in the west through our Niagara project, up in the north on the St. Lawrence project. We actually share the dam up there with Canada. Interesting fact is the border runs right through the center of the dam. In the Catskills, we have some large pump storage units here, 4 of them. And I think it's the biggest battery that we currently have in New York State. And down towards New York City, we have some fossil and we also have some small hydro assets. So this is really just a summary similar to Duke, I guess, in capacity, 5,800. And this is about 1,400 miles of transmission line when you add it all up. So when we took over something called the Canal Corporation, this is a map of that. It also goes across the state. So you have the Hudson River here, of course, up to Albany. And what was built is the Erie Canal, which took you all the way over to Buffalo and into the Great Lakes. So there's a connection to Lake Erie through the Oswego Canal. There's a connection to Lake Ontario, to some of the Finger Lakes down here. And if you further go up the Hudson, there's what's called the Champlain Canal, and that links to Lake Champlain and then the St. Lawrence River. So it's a pretty extensive system, over 500 miles. I just put a note here. It's an engineering marvel in its day, and it's an engineering marvel today. Talking about the age of some of the dams, almost all of the new Canal Corporation structures are over 100 years old. Some of the dams go back to the old Erie Barge Canal, which is 200 years old. We have some reservoirs here that were built before the Civil War and they had to drop out their tools. They fought the Civil War, and then they came back and finished the reservoirs. So we have some old infrastructure for sure. Back to some of the points that were made earlier, really about safety. It is our number one focus, and I put a quote here. It's in our DNA. Back to what Paul was saying, we used to have 2 nuclear power plants, one BWR, one PWR, and I think it's really the legacy of that focus that has carried us through. Even though we don't have nuclear today, it's still in our DNA. So we have, as Ray reported there, we have some KPIs that really go up to senior management on safety of our own personnel, as well as the public. And that is throughout the organization. All the employees, as the question came up there, you know, when we onboard, we have mandatory training. Some of it is tailored to dam safety if that individual is in dam safety area, as well as some cross-functional teams. I heard some mention of that earlier. And I think we kind of pride ourselves on that is for EH&S, which is our environmental health and safety, because we do cover the whole state, we gather everybody together and focus on safety issues, environmental issues, as well as we have an electrical safety committee because primarily we are an electric utility. But we also have over here on the right, I put the Dam Safety and Civil Works Committee, which is by far my favorite meeting of the year. We meet several times a year, and it really gathers all the civil engineers, if you will, but it's cross-cutting. We have folks from environmental, we have folks from operations, security, and everybody comes to the table and we share experiences, lessons learned, and do presentations like this to each other and learn from each other. So it's really a very beneficial forum. And when we took over the Canal Corporation in 2017, we pulled a lot of those folks into the same environment. So they're learning and we're learning from them as we go forward. Some of this I took right off our intranet, but really it's just a focus on safety, if you will. As you can see here, safety first. And these are some of our values that we put together a calendar that we distribute to all the employees. And these are some of the quotes from that calendar. But you know, a lot of talk today about resiliency. That's really another thing that we rely on, so to speak, and really the trust that we have for each other and the respect we have for each other. I think that's really paramount. Just back off a little bit. Who is the New York Power Authority? In the left, upper left here, this is a shot of our Niagara Power Project, and you can see the reservoir back here. So we do have 12 units here that act as a pump storage. You can't see it, but there's an underground tunnel here that connects to just upstream of Niagara Falls, and we siphon off the U.S. share of water. And some of it we pump into the reservoir, and the other comes kind of as a run of river. This is a 300-foot Francis turbines. There's 13 of these here, each 225 megawatts. So this is our largest hydro here at Niagara. The first plant we ever had was the St. Lawrence Power Project Dam, and that's where Denise Bisnet actually worked, and that's where I first met her. But this is what's known as the Long Sault Dam. It can actually pass the entire St. Lawrence River flow. There's 30 fixed hoist gates here, and this is the main power dam. This curved dam here is actually in the background here, so the river flows in this direction. The Canadian border is right here, so we have 16 propeller units here. The Canadians have 16 on their side. This is that pump storage plant on the upper right, and that's about a 1,100-foot vertical drop here. You can't see it because it's a submerged intake, but this is the upper reservoir, and that's about 1,000 megawatts capacity, 1,100 megawatts. And then we have some small hydros that are scattered around the state. This is just a couple of typical small hydros, but they have pretty significant high hazard dams there as well. This is the barge canal system, kind of a profile. As I mentioned, it connects to Lake Erie at one end. It connects to Lake Ontario at another end. The Finger Lakes down here. And there are 57 locks throughout on a hydraulic point. There is a high point here, so we have to have feeder canals that come in to this point and to this point to add water so that we can actually lock boats through those particular points. A lot of infrastructure and a lot of challenges, and I'll show you some of those later. So what's our philosophy? It really is safety is our top priority, as I mentioned. So here in our headquarters where I am today, we have a dedicated staff whose only focus is dam safety. We also have folks at each of our regional power projects, and it's folks in operations as well as dam safety engineers working together in close coordination and collaboration. And that's another point that was raised. Really, we have to do that. And I think this is that cross-functional. I would really emphasize that that's a very, very important thing to do, because diversity of thought, right? You have some folks in security, you have some folks in operation, as well as maintenance, and everyone has a different point of view, but it's really pulling all that together, and you do learn from one another. So I would just sum it up in these 5 main bullet areas, you know, and those are the folks that we bring into these meetings. But surveillance and monitoring, we do have some remote monitoring, as has been mentioned. But you know, this is the worst case scenario, so we do have to plan for that. So we are focused on emergency action planning, as well as training. We have modules that we actually record, and we do live presentations as well as some that are recorded. And of course, we have a work order management system where we track inspections, the FERC inspections. We are regulated by FERC. The Canal Corporation is regulated by New York State DEC. So we conducted at the Power Authority an independent audit. This is one thing that FERC requires of our dam safety program. So this is, I believe, 2019 are these results. And these are some of their findings. And again, you can see the focus on training and communication. I mean, vital components to a dam safety program. Making sure everybody is aligned. And they didn't just review the management. They went out into the field and they reviewed, interviewed operators all through the ranks in different projects. And really, I think what we have provided is a clear message that safety is paramount. And it really, I think by having that atmosphere and that culture, if you will, it compels everybody to want to achieve. And I think Paul alluded to that earlier. You know, if you strive low, you're going to hit low. But if you strive high, you're going to achieve effective dam safety. So that's what we try to do. But we're not going to rest on our laurels either, right? That complacency component, that's something that you know, we don't do. So even though I think we have a fairly robust dam safety program, we did have some recommendations, and these are right out of the report, and it was really to have our particular governance of the dam safety program reaffirm the language that this really goes up to our board of trustees, so that it's really up to that level of the company, that they have an understanding of, you know, what the issues are, as well as the funding and resources that can be allocated for it. So we have implemented that. The other one was really to have our CEO put out a blanket statement to all employees about the importance of dam safety to the organization. So this was done at the Power Authority. And this last year, we actually increased that language to include the Canal Corporation. So again, they can kind of learn from some of our best practices, and to try to change and implement change of culture into the Canal Corporation, we reaffirmed that, you know, from the top down, the importance of dam safety to the organization. Just some instrumentation, if you will, that we have. This is at our St. Lawrence plant. So we do try to use as much current information as we can, you know, always trying to get the best utility practice into play here. So this is some sonar where you can get very refined measurements underwater to see what these structures look like. Even though this plant was built in 1958, it's still in pretty good shape, but we were able to confirm that by doing these underwater inspections. And these two particular structures here are over 100 years old. 1915, I know that this dam was built, and this dam is about the same vintage. And, you know, we can use that same technology unmanned. It's a heck of a lot better than some of the diving inspections we used to do in days gone by. And you get a beautiful picture, and it's in 3D, and it's really a timestamp. And we've actually found some scour holes that we did not know existed using this technology. So that really helped us quite a bit. So the culture, I think really that's what it's all about. And we, again, you can see the two words I chose here is really respectful and trusting, right? That's the environment we really try to instill. I think Ray alluded to near misses, right? Those are shots across the bow, and we take those seriously and look to put corrective actions in place for those. We actually have an 800 number where anybody can call and report whatever they want anonymously, and we have an ethics officer that monitors that. But everyone's encouraged to be curious. I think that's an interesting word too, because you know, questioning the status quo about how we do things, as well as, again, soliciting everybody's opinion. When we have these cross-functional meetings, we always do a roundtable, as I think we are going to do at the end of this meeting. But, you know, where anybody can say whatever they want and bring up any issue that they want. And as I mentioned earlier, we conduct these, we share lessons, best practices, and when we do have an incident, you know, we conduct what's called the root cause analyses to try to get down to, you know, what is really behind the issue that happened, so that it does not happen again. And we also have metrics for we call these things PNCs, and this is really more on the NERC side of things. It's on our transmission compliance end of it, but it's the same concept where you can have a self-report of an issue and you investigate it and you put a corrective action plan in place. So this is the NIPA culture, and this is really our challenge, was to instill that upon the canal system when we first took it over in 2017. And this gives you some, I guess, a little map here. Again, this is Albany, and way on the west here is Buffalo, but each dot here represents an asset. And, you know, here's the count, 909 water impounding structures. It's extensive. It's a lot of infrastructure, and it's a lot of old infrastructure. So what do you do when you first are given the opportunity to oversee this amount of infrastructure at this age? Well, one of the first things we did was really go through all the existing documentation we could. We really, I think, did a broad brush risk assessment. We hired a consultant to help us, but we went through all the existing reports. There are, you know, this many high hazard dams, intermediate and low hazard dams. You know, we use GIS. We looked through all those reports, and we are still classifying. As you can imagine, some of this infrastructure is very old, and there are some of these that weren't classified by the states. We've actually gone back to the regulator and given them classifications and reclassified some of these structures that weren't in the high category, but we felt that should be. And that does kick in a whole lot more inspection requirements, EAP requirements, things like that. So that's what we did when we first took over the Canal Corporation. Is we set up from scratch. It did not exist before, but we put together an organization of a dedicated team of engineers up in Albany. That's where they're headquartered, but they're focused on dam safety and only dam safety. And you'll see some of the work they're doing. It's pretty impressive what we have done. But again, we don't rest on the laurels, but we did that risk assessment. I think it's been referred to in this meeting as it's a living document. The more we learn about conditions, consequences, likelihood, it really changes how you prioritize these things. And we have definitely seen that, as we continue to learn. So we actually audited a dam safety policy. We put a lot of governance in place that did not exist before. And I know Paul alluded to that earlier also, is, establishing these policies and procedures. It's really key so that folks know what are their roles and responsibilities. How do they fit in? How does the whole thing work? And that also helps with onboarding folks. You don't have to rely on in-house knowledge. You have written it down somewhere. And, we've had turnover in staff too, and it's really key that folks have something to fall back on. But when we reviewed some of this infrastructure, we knew we had to develop at least 20 new emergency action plans where they did not exist before. And we also wrote a policy on how to activate these EAPs. So again, we're turning the tide here. We're trying to turn the Titanic, with the culture by identifying some of these things. As you can see here at the bottom, there's several bulletins that we wrote. I know Dell was referring to the geotechnical aspect. So we're using a lot of the best practices from FERC, and we're adopting those, into the canal going forward, even when they're doing construction work, to have a temporary construction EAP in place. So that was really the goal, if you will, for the Canal Corporation, was to prevent any uncontrolled release. That's our ultimate goal. But how do you do that? You do that, many ways. But first is getting that governance, right? That's critical. But we also put a training program, again, specific to dam safety, to increase awareness. And, we went across the board to the folks, and over the years, the canal has had folks they call bank walkers, and they actually walk some of these, there's hundreds of miles of embankment that are prioritized, but they really didn't have, exactly what are they supposed to be looking for. They knew they were looking for leaks or sinkholes or whatever they could find out there and report that back. But we tried to formalize that now with some training and awareness, so they actually know, what to look for and why they're looking for it. And we've also worked with the asset management team, which they're also trying to increase now at the canal, is really the focus on asset management and work management plans. So we've done a lot of work in that area, but again, we have close coordination between us in the dam safety program and the asset management team. We've used a lot of consultants because we do have resource constraints, but that's part of the work we do is do that. They do participate in the Dam Safety and Civil Works Committee, and really, again, that collaboration to make sure that we are communicating, they're getting the support they need, and also to educate a lot of the staff on these assets. So, a few slides really here. Sorry, they're just in bullet form, but it's really to identify some of the key points, I think, for the Canal Dam Safety Program. So, records management. These structures are old, so we actually have to go back to the State Museum where some of the original documentation exists, some of the old contract information. So we have identified those important documents, and we're putting them into databases that can now be researched. Again, from the top down, we have a risk management committee here at the Power Authority, and we are making presentations to them to keep everybody informed as we acquire these new assets and are learning from them. And again, what I'm trying to say here is we're instilling our best practices that we have at the Power Authority into the culture. And that's a lot of education and a lot of meetings through Zoom, through Teams, that we're all learning from each other. As I mentioned, we put new EAPs and response plans into place. I have an example later on where we actually looked at something called tertiary EAPs, which I'm not sure is a real term, but there are dams that are outside of our dams that if they failed would have impact on us. So we really expanded our look at, where is the real risk coming from that could impact us, our operation, our people, or the public. Again, some of this, the point was made earlier, I made a note here about regulatory compliance. I think our view is, that's a byproduct of doing good practice. So if you do good practice, the byproduct is you're going to comply with the regulatory requirements. But that being said, they do have a certain frequency on when we have to do these EARs, they call it in New York. They're basically a Part 12, if you will, on the FERC side of things. It's an in-depth dam safety inspection. We're putting together I&M plans, we call it, inspection and monitoring, just to be sure that we are not only complying, but our folks are aware, of these of the infrastructure that we took over. And as I mentioned, we did a very high level risk screen to review really what's the impact. If you can imagine, the Erie Canal was really responsible for settling the West. Right. I mean, that's if the history of the country is that was a really important vehicle at the time to migrate westward. So there's a lot of infrastructure out there that's old, and we don't have much data on it. So we really had to come up with a means to do it. And over time, subdivisions have been built where subdivisions did not exist 100 years ago. And folks do like water property. They like to walk along. We have a lot of trails along the shore. So a lot of infrastructure was built, and that really changes the risk, right, to the residents and to us, right? That's our risk profile. So we always have to be aware of the population at risk. And I think I alluded to that earlier, but that's one thing in the future we are going to be looking at more closely is the population at risk. And should we recategorize some of these studies in some of these structures? Training and education, these are the types of things we include. Public safety is really number one, but we review a lot of the things that Dell went through, like dam failure case studies, so that folks can learn, as we learned today from Dell, about what happens when some of these structures fail. Governance, as I said, is key, as well as looking forward. Right, we're always looking forward. We're always trying to improve. I have a continuous improvement slide, and I know Ray had one too. But that's really our focus is on the future of making us improve. So one of the things we're going to do, and there's an organization called CCRM, and it's a Canadian organization. It's similar to EPRI. It's kind of a research organization that has a lot of utilities involved, and they have something called a maturity matrix for dam safety programs. And that's one thing we're going to be embarking on in the future, because we're always kind of shooting for that North Star, right, of how we can improve. And we're going to be auditing the bulletins that we just wrote. And something that Rune actually referred to as, what are those dam safety assumptions? And to be sure we're consistent about it, that everybody is aware. So we're going to do really a review of that in 24. there are resource constraints, there are budget constraints, so we're trying to prioritize as best we can. You saw the depth and the breadth of the assets, so it's a challenge for sure. So one of the first things, as I mentioned, we looked at hazard identification of these structures, and so we did write 20 new EAPs when we took over all of these assets. And we're reviewing all the reports that have been written to date, and we actually turned our, we let the regulator know that there are assets out there that should now be in a high hazard category that was never in a high hazard category. So, the more we learn, the more you dig, the more you learn, and we're learning as we go. So in New York State, I know the question came up earlier about the different categories. We do have 3 in New York State. New York State is overseen by the DEC, our Department of Environmental Conservation, and they categories. But the high hazard is what was mentioned earlier, where you could have potential loss of life. It doesn't mean the dam is in that situation, but you could have potential loss of life. And we have increased the numbers for the canal. You cannot see this Excel spreadsheet. I didn't really mean for you guys to be able to read it. I think the point was, this is a tracking system that we have initiated, and it's color coded here in terms of priority. But it's our way of taking that long list of assets that you saw in the beginning and trying to put them into different categories of risk, so that we can come up with a plan for the future and how to address some of that risk. So the canal's always had something called SIMS, which is a canal infrastructure management or information management system. We also have a Maximo database, that's a work order database. And so we're looking at ways to take a lot of the data that was really scattered, and now we're trying to centralize this into a database that everyone has access to, as well as tracking the correspondence and whatever commitments that we've made. And as I say, it's a tool to help us prioritize some of the work, because the categories would be the consequences of failure, the likelihood of failure, and the condition rating, right? That all goes into how this is prioritized. So just to step back, I thought it'd be interesting just to see some of the infrastructure out there. This is a unique structure here. It's a double lock system, actually, but there are 57 locks, and this little GIS up here shows you where they're located. This is one of the old drawings, if you will, that shows a 3D representation of the lock. Very interesting to go through some of those old drawings. There's something else we call guard gates, and this is a big one here you see in the bottom. Basically, I look at those as valves. If something happened in the canal where there was a release of water, either to the north or to the south, this is a way to limit the uncontrolled release of water by dropping these gates. So we're looking at the response plan to get folks out to drop these gates, as well as the condition of these. And there's 26 of them, again, scattered across the state. Fixed crest dams, this is, I believe, the Delta Dam here. But again, they are scattered throughout as well. But 54 of them is quite an inventory to look at. We have what we call Tainer Gate dams, which just have rows of Tainer gates. And something we call waste weirs. It's not environmental waste. It's just if there was, because the canal actually cuts through watersheds. You saw by those high spots here in Rome, there's actually a watershed line that runs through there. So you do have runoff that hits the canal, and these waste weirs are, I call it a pressure relief valve, right? You can actually allow some water out of the canal by opening some of these slide gates. But these are all water control structures that have to be inspected and have to be evaluated. So that's part of our inventory as well. And then embankments, right? There's miles of them. And because of the age of some of these, the unfortunate, from an engineering perspective, is, there's unsuitable vegetation, right? It's inhibiting our ability to inspect certain areas. There are trees growing where we don't want trees to be growing, but there's also the public involved because they have gotten accustomed to seeing trees and they don't like them to be cut. I'll put it that way. But we're just looking at it from the public safety perspective. So we have a lot of outreach that we have conducted and will continue to conduct. But there's also environmental concerns. And I didn't mention it earlier, but another complication is the entire canal has been designated as a National Historic Landmark. That impacts how we can do rehab, and it really is part of the criteria. So there's environmental as well as historic constraints on what we can do there. So again, I drilled down here a little bit to give you some insight into these new emergency action plans. We have a total of 31. That's our inventory of emergency action plans at the canals. We also have 6 for the power authorities projects as well. But they cover quite a few dams, and we've had to make a lot of outreach to the different counties involved. I know Rune was asking about that earlier, but that's part of the effort, is really to educate the public about these structures that they may have not known about. These may be public officials that were unaware, because really until we reclassified some of them, they weren't a high hazard structure, but we felt they should be. So we have actually met with a lot of them, and it does become quite a burden to keep these updated and fresh. We have to do new inundation studies, make sure the notification flow charts are in place and they're up to date. So there is a maintenance, if you will, to these documents that has to be kept up to speed. This is that tertiary issue that I was talking about before. So this is similar to Dell's map earlier, where he had the entire country. I just kind of zone in here on New York. This is from the National Inventory of Dams. This over 5,000 dams in New York State. But when you drill down, there's 1,000 that are high and intermediate hazard dams. And if you drill down further to what we're focused on, this red line that's drawn here really encapsulates the watersheds, if you will, surrounding. If you can remember, the canal infrastructure kind of runs through the middle of this. But these are the watersheds that could impact canal structures. So we looked at all the high hazard dams here that if they did fail, and there was a cascade failure, for example, they could have some impact on the canal infrastructure. So we're actually doing outreach to other dam owners to get into their emergency action plan, so that if something happened, we would be on their notification flow chart, because they would have some impact on our structures or on the public. So I very interesting exercise, used a lot of different databases, National Inventory of Dams, as well as FEMA websites. A very interesting exercise. So this is my turning the tide. What we're trying to do is really, take the best practices at the Power Authority and instill them in the canals. That's really the bottom line. But it takes a lot of work. It takes a lot of meetings. It takes a lot of awareness training, collaboration, coordination, communication. We refer to those as the 3 C's. It's just constant, and we can't let up on it. But the last bullet here is, this is unique and challenging. They're historic structures. They're an engineering marvel. But to Rune's point, we have changed, right? The design assumptions have changed since the Civil War, certainly, until today. And you saw Dell's, impact of climate change. So all of that factors into how we evaluate these structures going forward. But we are continuing the transition, right? These are my continuous improvement. We're not resting on our laurels. We've found out a lot. We are learning more as we go, but we're really trying to improve our decisions that we make, because we do have tangible limitations on staff and capital, the resources available to us, as well as these other constraints I mentioned earlier. But that's really our charge. We have the standard of care for these. We are the stewards of these assets. We take it seriously, and we're moving forward with that in mind. These are the types of things I mentioned a few earlier that we're looking for. We're looking to this maturity matrix assessment. FERC has actually embarked on something recently. I think more is coming on this, but some risk-informed decision making. And I know Dell's not here now, but USSD actually had some training on that recently that FERC is going to be adopting, and it's going to factor into how we look at our assets as well. But we certainly already have a risk register that we're using, and as we learn more and more about these assets, we're going to change. And really, I think it's all for the better, but it does take time. So I guess in summary, I would just, I've been at the Power Authority a while here. I think we have definitely increased and learned over the years. I think we have learned from our nuclear experience, and we've indoctrinated some of those principles and how we care for the assets. And we have a pretty robust culture here, and we're sharing that and leveraging that with the Canal Corporation in all the areas you see here, the governance, the training, and keeping that open line of communication and sharing of best practices and experiences. It's very valuable, and I can truly say I've seen change. It's not where I want it today, but it's getting there, and it's really rewarding, I think, to see that. And here's a bullet that we just added, but in New York State, NYPA really owns most of the high and intermediate hazard dams. So it's certainly something that's on our radar from a risk posture. And I just close here with really it's non-compromising, right? These are our values, as I referred to earlier, and they're instilled throughout the Power Authority. And that's the work going forward is to leverage that for the canal. So that's all I had, Rune. Be happy to take any questions if anybody had any.
Yeah, great. Thank you for the fantastic presentation. Are there any questions or comments from our audience out there today? Oh, yeah, go ahead, Mark.
Thank you very much for that excellent presentation. I'm particularly curious about the root cause analysis system that you use, and if you employ different ones for different types of situations. That is an issue that I think a lot of organizations struggle with, all the way from blame the victim to a very invasive and perhaps somewhat, in some cases, wasteful process that's applied to more mundane situations. Can you comment on that, please?
Sure. I guess as an electric utility, it's something that we take very seriously, because on the electrical safety side of things, it's paramount. But so across the, we have even done it, for on the dam safety side of things. But I refer to it as the 5 whys, and you keep drilling down with the why question until you finally get to, well, but for this, it would not have happened. So that being said, I would say there isn't a universal approach to it. I think for the more critical things, where if there was a life safety issue involved, we have a cross-functional team again that is teamed up and focused on that, and wherever the incident occurs, we take that part of the organization out of the assessment, so we have really fresh eyes coming in to review it, so that we have an impartial, independent understanding. And we put somebody on point in charge of that investigation, and they formulate a team depending on the issue, right? Everything depends, but depending on what it is, you get some subject matter experts across the organization, and everybody is focused on it. And there is a methodology, for a root cause analysis. There's actually software out there that helps you through the process. But if it's one thing that comes out of it is human performance factors, and I know Ray was alluding to that in his presentation. But the human performance factor is it down to just that one individual's performance, or is there some kind of a systematic issue at hand? So, if you just took another person and put him or her into that situation, would you get the same result or not? So I think that's one thing we're trying to factor into too, not in a punitive sense, but just in a sense of, was it actually a performance factor, or is there some systematic error in the way we do things? So it's kind of there's a lot of different approaches to it. I think it depends on the magnitude of the issue, but there is software out there to help you on the larger ways of doing it. I've done some of them myself, and it's very educational, actually, in terms of driving down into finding out really what happened. And you can't always believe a lot of the first reports, so there's a lot of evidence review. We actually, if it's an operations issue, there's phone calls. We have recordings that you listen to find out exactly, was it an error in communication, right? We have we have policies on safety, and there's like a third party, a three-part communication scheme where somebody says something to somebody else, they repeat it back, and they repeat it back, so that there's a clear understanding, like, I'm working on this piece of equipment and not this piece of equipment. I mean, it's just vital to the way we do things. And so we do have recordings that we listen to. So it really depends on what the issue is and what the magnitude of the problem is. And you dive in as deep as you need to go.
Thank you. One quick question connected with that, and that is one system that I'm somewhat familiar with is that of the Taproot system, which is a very designed originally by individuals working in the nuclear Navy, and is used to address very complex systems. And I don't know if you've experienced that, used that one, or a different one, as you mentioned, for a more consequential and complicated fault path.
Yeah, Mark, we have used it. We do have it, but it is for something that is very complicated, and it's really hard to kind of peel back the layers of the onion to find out what happened. But we definitely use Taproot, as well as a simplified methodology.
Thank you.
Tony.
Yes, great presentation, and you may have covered this when you were talking about your documentation tracking spreadsheet. But I was curious for the regular or maybe periodic or even special inspections that you may do on your various facilities. Are you tracking those in a certain way? Are you using your asset management software to track and be able to retrieve any trends that if you're going out to look at the same structure over and over again, or how are you sort of managing that data?
Yeah, so I guess it's a kind of a two-part way of doing it. We have a Maximo database. I think I alluded to that. It's a work management system, so you build in a work order, and that's one thing we track on the NIPA side of things, and we're trying to push that into the canals. But on the NIPA side of things, dam safety has its own category within that work order system. So if it's related to dam safety, it kind of bubbles up to the top, and we monitor those for completion. So it's a work order database. It has a description of the task. It has a description of the beginning date, the end date, when it has to be done. And you can query that database and get reports from that database that will tell you, and again, there's different levels of criticality, I guess, for those work orders. We have a level 3, 2, 1 that we look at. And depending on how you query, we actually have metrics that we're looking at those work orders, and we issue a quarterly report. So when we pull all that data, we make little bar charts out of it, and you can see, you know, by region of the Power Authority, you know, where folks are in terms of closing out those work orders. So there's definitely metrics, you know, that we review for that. On some of the other tasks, we do have some spreadsheets that are tied to work orders. So there could be an Excel spreadsheet where I'll say FERC in this case, where we have certain commitments that we have to meet for FERC. Those are written into there so that we can track them that way. On the FERC side of things, again, we have to issue surveillance and monitoring plans every year. So we have, again, they're all acronyms here, so forgive me for that, but it's a DSSMP, which is a Dam Safety and Surveillance Monitoring Plan, and then we have a Dam Safety and Surveillance Monitoring Report. And so you combine those two things. You have a plan and you have a report, and they should coincide in terms of, you know, how you're tracking closure of some of those work orders. On the canal side of things, they have historically had this canal infrastructure information and management system, and that we're trying to migrate and merge with Maximo, but it's the same type of thing. It's a repository by asset class, and then by asset, so that you can actually, you know, zone in on a particular asset and get all the inspection reports that were done, you know, any data that was done, diving inspection report, all of that is really tagged, you know, in that database to that particular structure, so that there is a way of getting some historical information out of it.
Great, thank you.
Cool. Any other questions or comments floating out there in the world? Don't all speak at once. Well, thank you, Bob. That was a great presentation. And I see Jason is now with us. Hello, Jason.
Hey, guys, can you hear me?
Yeah, how do I correctly say your last name?
It is Fugate.
Fugate. All right, well,
Yeah.
welcome. We will pass the ball over to you. And we kind of just did self-introductions at the beginning, so I will continue on with that trend.
Okay.
I'm going to make you the spotlight person.
Perfect.
And let's see, I think you should have the ability to share your screen.
Let's see what we got here. Hope everybody's well. I apologize for being a little late. We had a previous engagement, but we're happy to be here, and I hope you guys are doing well.
Yeah, no problem at all. Thanks for jumping on, and really a big thanks to everyone for taking time out on a Saturday to participate in this this workshop. So with that, Jason, the floor is yours.
All right. Can you guys see my screen okay?
Yep.
I'll take that as okay. Perfect. So it was self-introduction. As Rune said, my name is Jason Fugate. I'm the Senior Manager of Occupational Safety and Health for Santee Cooper. I am by no means a dam and dike expert, so what I was asked to focus on here was we've had a fairly significant evolution in our safety culture, which has allowed us to capitalize more on the eyes and ears of those in the field, and we've gotten tons more reporting, we've gotten ton more buy-in, et cetera, et cetera. So we'll kind of walk through that. But as far as a self-introduction, as you said, my name is Jason Fugate. I'm a certified safety professional. I've been in health and safety for 30 years. I worked in large engineering construction projects, one of those being the World Trade Center recovery back 20 years ago or so. I worked in the nuclear industry for a bit. I've worked in manufacturing, and I've been with Santee Cooper since 2016, the end of 2016. And, we're pretty proud of our safety efforts and the evolution, as I said, of our culture. And just want to share some of the things that we've looked at, and we've sort of framed it around some of the key principles that came out of the Deepwater Horizon project. And so I've kind of fit things that we've done inside that. So we'll get into it. So, okay. I didn't mean this. So Santee Cooper, we're a public power provider in South Carolina. We have about 2 million people that we serve. Formerly the South Carolina Public Service Authority, created in 1934 as a rural electrification and public works project. We generated its first electricity in 1942, so it was 80 years ago. We just celebrated that milestone. We created Lake Marion and Lake Moultrie with over 40 miles of dams and dikes, and then at the time it was the world's highest single lift navigation lock. Our generation is made up. We have a couple coal stations, a natural gas, a hydro with a small unit on a separate spillway. We have some landfill. We catch the methane off the landfills. We have a few combustion turbines. Transmission, we have about 52,000. That's not 5,200. Excuse me, 5,200 miles of transmission lines, and our right-of-way covers about 40,000 acres that those guys manage. Distribution is 170,000 plus direct serve customers, mainly in the Myrtle Beach area. We're located outside of Charleston, is our corporate headquarters, but that's mainly where we serve. And we also have regional water. We have 2 water plants where we do water for a couple of municipalities. I think it's around 40-something million gallons of water a day that we get out into the community.
Hey, Jason.
Yes.
Your slides aren't advancing for us on the screen.
Okay.
Are they advancing for you?
Yes, sir.
All right. Maybe do you want to try stop sharing and then resharing? Maybe it just got frozen or something.
Let's try that. I stop sharing. And let me try it again.
Yeah, no worries.
That's all right.
It's always something with technology.
Yes, sir.
All right. So I see that you're on slide 4.
Yes, sir. That's where I'm at.
All right, cool. Thank you.
Okay. And so this just shows when we're talking about our culture and where we came from, our evolution of our safety incident rate. And if you see down the last 4 or 5 years, we're down. We've cut it in a quarter of. We're down in the 0.2, 0.3 range. And we just wanted to kind of explain how we got down to that. A 10-year history. Now you got is the screen working now, Rune?
We're still on slide 4, so maybe it's the presentation mode that it doesn't like. You can probably leave it in non-presentation mode and just go from slide to slide. Yeah.
How's that?
That is much better. Thank you.
Okay, great. Thank you. And so we're starting to have a lot of success now from 2000s. You see in 2015, we're in the 1.2 range, and we continue to work on our culture, and our incidents are getting better, our incidents are getting less severe, but what it's done is this opened up the culture to where we're now getting tons of feedback. We're getting tons of reports from those in the field, and it's a lot of it's to do with how we've kind of changed our approach. Prior to 2016, we had a very, very punitive system of how we manage safety. If you got into an incident or you reported an incident and et cetera, it was a big deal, and it was never in the favor of those who either got hurt or made a mistake or whatever else. And it wasn't based on a behavior. It wasn't based on anything but an incident occurring. And so we kind of came in and we took a different approach. And, if you look at our leadership commitment, a respectful work environment, environment of raising concerns, effective safety and environmental communication, personal accountability, an inquiring attitude, hazard identification, work processes, and continuous improvement. And so we're going to kind of go through these and just show us what we've done. And this is not a catch-all for everyone, but for us, these are the things that have worked and has helped us get us to where we're going. We're not there yet, but we're definitely working on it. So the way we were set up, we've got 46 locations, and we had all of our safety folks basically in one with one person in Myrtle Beach. So you had basically no direct interaction with our line crew or our lines of business. It was more safety by ad hoc, and what was occurring as we were going through and doing inspections, finding issues and raising it all the way up to the C-suite, and it would come back down a little bit harder than it went up. And so we realigned the safety support. At this time, nobody wanted safety around them, with them, on their jobs. I had a line crew supervisor told me last week we were doing a celebration that he would actually stop jobs when we came out, or he would cancel them because he didn't want the scrutiny, he didn't want the pain of the visit to happen. So one of the things we did was, and I've heard this term a while back, is because we used the culture to break through the bias. We had guys that were able to, and girls, that were able to align themselves with the work groups and the management of those groups to help us break down those barriers to where we started getting feedback, issues reported, and we were able to learn the business from a standpoint too, where we were able to help them become a little bit more efficient in the things they were doing. So we also focused on our internal safety team building and support within those guys, and developing the lines of authority. We've crossed those barriers a few times, but who does what, when, and where, and if there's an issue in another area, who takes care of it. And because those guys have built those relationships to go through and work with the departments to mitigate anything that popped up. We increased our frequency of reports. These were the good reports to our C-suite and our C-staff executives. And we wanted to make sure they were fully aware of our activities and what was occurring. We increased, we have a safety council, a corporate safety council, which is made up mainly of upper senior managers with authority for operations and some of our support, legal, communications, risk management, et cetera. We increased the frequency of those meetings and shifted the focus of that operational leadership to proactive activities. And with what we were doing in the past, where this occurred on this day, et cetera, but we were focused on the lagging indicators versus the leading. And then we also put an emphasis on the, I'll say R+, this was a positive reinforcement. We wanted to make sure that the people who were doing good were recognized for the tasks that they did. But we also, there were some negative pieces in there. We had to hold people accountable. So, but working with the direct management of those, the folks doing the work, including our hydro and our stations, et cetera, we were able to them to start understanding where we were coming from and that we were not the enemy. We were a support organization to help them manage their safety and move forward. Respectful work environment. Again, that realigned the safety support. We and it's dual phase, but we came in and now it's not a punitive issue anymore. They were, they welcome us when we come out there. We've been doing lunches with those guys, and we're cutting up and having a good time. And before, they didn't want anything to do with us. So we've broken down those barriers, and that also helped us with the work environment. I mean, we have guys that do overnight work for line crews, et cetera. Initially, some of our safety guys would go out and work the night shift with them and cook lunches for them and be the gopher on the crew, and all at the same time keeping an eye on their safety and the activities they're doing, and pointing out areas of, if a supervisor's not supervising, he's jumping in and working on a piece of equipment, et cetera. We would challenge those guys and have him focus on his crew instead. raising concerns. So we changed our disciplinary action guide. It was based solely on an incident occurring and nothing with the behavior. So we've modified that to focus on the behavior, incidents with what the intent of the actions were. And as I mentioned earlier, it was a fairly punitive system, and we had a behavioral consultant come in, and he described it as a whack-a-mole approach. I mean, you're going to always have somebody to hit over the head. And when that happens, people are going to run the other way. So we try to be more inclusive and move away from that, and which has helped us out. Communication, we're lucky enough that I have basically a corporate communications person that I work with regularly. We do daily toolbox topics that we send out for the corporation. We do a weekly newsletter, and we do monthly or quarterly magazine articles around safety and health. We do monthly reports that go out to everybody. We do post-incident reports, and including what I put in here is SERs. SERs are a significant events review. It's just a snapshot and to give people an understanding of what occurred. And those are centered on our recordable incidents, our preventable motor vehicle accidents, our near miss and hazard reporting. But we also do one for good practices. And the last one we had was just came in 2 days ago from a dam project on our spillway. They were putting in the what's the fish? You guys know what I'm talking about. The fish attractor, the fish mover, or the gets fish from one side to the other safely.
Fish passage?
Yeah, that's it. But the walkways were messed up, and some of our guys and they were contractors, but some of our guys took it upon themselves to make sure they had a great walkway. They didn't have to. It was a contractor's responsibility, but they helped them. We had material, and it made the whole job that much safer. So we would do an SCR on that to pass that on. We do lessons learned, and we shared the findings throughout the company. We've modified our reporting on our incidents. Prior to 2016, we would count a motor vehicle accident where you backed into a mailbox. Eventually, it would just get lumped into one incident. So we started categorizing what the incidents were. Is the recordable, is the first aid, is the near miss, is it a property damage, et cetera, et cetera. And so we could start focusing on individual metrics versus a lump that contained everything. So that's helped us quite a bit. We give immediate feedback on a near miss being reported, and we also give immediate feedback once it's completed. So if someone submits a near miss report to us, we'll email them, call them, find out the details of what they're doing. We'll send a guy out there from our team in whatever area he's looking at. They'll come up with a solution. And when it's completed, we'll come back to the person who submitted it and say, hey, thanks for submitting it. This is what we've done. Here's the end of the report. Operational units, we focus now individually on specific goals for those guys. And that's really heavily weighted on safety performance. And it's getting more and more traction as we switch to rates and we drive to zero. One of our milestones from doing this is we just had we have 11 transmission line crews with a right-of-way management. It's the first year in our 80-year history of the company we didn't have an accident. So those little small wins we celebrate, and we want to make sure that we as our line crew manager was saying, this is the expectation. We can work safely. We did it for a year. We know it, and part of that is their reporting. They have a huge, our transmission guys right now are our biggest submitters of our near misses and incidents and hazards. And so it's helped them come a long way. Personal accountability, again, it goes back to behaviors. We have in the past, if you got hurt, it was what we termed as corrective action. We didn't think that's fair. I mean, there's some cases that happen. We just had an incident the other day where a guy got rear-ended. He didn't do anything wrong, so why are we going to punish him? When we try to correct someone's behavior, it's not to punish, it's for him to learn and to learn from that mistake. We want to make sure it's at the appropriate level. few years ago, if you backed into a mailbox, it was raised all the way up to the CEO, almost the same as we had if a serious incident occurred. So we want to make sure that we keep everything in perspective as it should be. We've got direct intervention with our intervention with our operational units. Our guys are there quite frequently working with those guys, and you can't do all the time, but so there's 46 locations. Those guys are on their own a lot of the time, and they have to have that accountability to do the right thing when they need to do the right thing, and that's the expectation. Inquiring attitude. We want to look for trends. One of the things we noticed when we were going through some of our reports, this was in 2018, that 75% of our incidents occurred after the 15th of the month, and then 50% of those occurred on a Tuesday. We didn't have the answer of why it was doing it, but we were able to present that and have maybe the crews internally could change something, modify something to get us out of that trend. So being embedded with those guys has gained a better understanding of the work. We're able to look for inconsistencies and correct. As Robert said earlier, we focus on the why. Why is this occurring? And the 5 why technique, that's a great tool. But we, as we're looking at things, why is this happening? And it's part human performance. So although we don't have a formal program, we want to go back and stop that at the base. This is a side note. I'm a big fan of John Wooden. The great UCLA basketball coach. He'd bring these guys in, and Bill Waltons and Kareem Abdul-Jabbars of the world. The first thing he would do would teach them how to put their socks on. He's at the very beginning, because they didn't put their socks on right, they were going to get a blister. And if they got a blister, they couldn't play. And so we want to take that back to why is this occurring, and what can we do to stop it from reoccurring? And that helps us create discretionary effort. And that's a term from some of our behavioral guys that I've worked with in the past. It's the difference between the you want to do and the have to do. If you have the have to do, or it's a punitive environment, you're going to get the exact performance that you asked for. If you can switch that around and focus on the positive, you get that discretionary effort, which is the want to do. And it's an astronomical difference in what you see from reporting, from interaction, from helping with procedures, et cetera, et cetera. Hazard identification, we introduced risk assessments back in 2017. Basically, that gave us several functions. It documented a job. We were kind of lax on our documentation, and that helped us, train the new guys coming in. Here's a job that we do. We're going to change a pole, or we're going to change a pump. This is the steps that we work, that takes to do this task. At each step, we can pick out a hazard or multiple hazards and put a control on it. We focus discussions on that, about hazard identification and risk avoidance techniques. We've emphasized our near miss and hazard reporting. Like I said, we went from 0. We got 0 near misses to we're getting 50 plus a year. We probably have 50 in place right now. So operational management is continuing to promote it. They see the value. They understand if we can catch something before an incident occurs, we're that much better off, and we can also share it because there may be other similar incidents occurring elsewhere in the company that can help us. Talk about work process, and we talked about risk assessments already, but that's a huge training tool. Will be a huge training tool for us if we can take guys with 0 experience or very limited experience and to show them how we do it. But it also helps us gain consistency, because we do have crews that work together from time to time, and they may do things a little different. And so when they get together, we want to make sure that we're doing it one way, because that will help us prevent something from occurring. And then lastly is continuous improvement. I always thought of safety was like the ultimate continuous improvement program. We're never good enough. We're always looking to get better. We're always tweaking. And so within our group, we have a 3-year strategic plan. We do an annual improvement plan. We continually tighten our targets. We're trying to get to 0. We're switching to leading indicators. I mean, our incidents now are getting to a point where if you would have one incident in the company, nobody would hit their goals. And so now we're focusing on, these are the activities that prevent things from occurring. And those are the activities that we want to manage and put metrics on, and incentivize people for to do. And we're working with operational management on our next steps and implementations for all of our new processes, procedures. I mean, we really have not introduced anything significant other than how we worked with the people and the you know, the breaking through that bias, so to speak. So, but we're happy with where we're at and where we're going. And I appreciate you guys' time. That's all I had as far as presentation goes. I'm gonna stop sharing.
Great, thank you so much. I don't know if you have a camera on or off, but it's off for us. Let's see. Any questions from our audience members? All right. So, Jason, thank you so much for that presentation, and a big thanks to all of the presenters today. You know, I did want to highlight that I think this is a wonderful opportunity for many organizations, and perhaps we can be of utility and assistance in kind of leveraging some of the experiences that the organizations, such as the ones who presented today, have already embarked on. You know, there may be the opportunity for us to kind of corral a list of very useful resources that we can point people to, share case studies. We kind of talked about some of those. Perhaps there's the opportunity for mentorship. So maybe some of the organizations that presented today might be open and receptive to helping out other organizations that want to kind of follow down this path to ask questions and point them towards you know, appropriate resources. And ultimately, I kind of saw the workshop today as the start of a longer term conversation where we kind of help folks that are interested in this topic make some advances within their own individual organizations. Are there any, we can kind of move this into an open discussion topic. Are there any thoughts or reflections or suggestions from anyone based on all the things that we've heard so far today? All right, not hearing anything. So the other thing that, Bing, go ahead, Bing. You're on mute. Yeah. Otherwise, I'll have to ask your question.
Okay, sorry, I muted myself. Okay. Thank you very much for all the excellent presentations. I learned a lot, actually. My question is more kind of in general, probably any panelists or speakers would like to answer, because my research is more related to decision making and for emergency response. We have been working on, I think, Rune and also Derek here, working on the human factors, human errors, especially during the incidents or emergency situation, from the the errors from the operators, workers in the front line, also back to the office headquarters. So what is the general consideration, in your organization, talking about those human errors in terms of the safety and the emergency management?
Ray, do you have any thoughts from the Duke Energy perspective?
Yes, I was bringing my camera on here. So from the emergency management standpoint, we do have a lot of procedures in place. We have to follow rigor. So we have ERPs, which are emergency response program.
Mm-hmm.
So a lot of that is dictated by a command control structure. With that being said, that yes, the field individuals, when say for instance a high water event is occurring, so we have field individual out in the field, and you have a command structure where they have to report what they see, and you try to minimize everybody's interactions, so that they're standard. So there's procedures in place where they need to follow, and we do train on this. We train it every year. We have our annual emergency response training, And we go through it and we interact with state agencies too in these training scenarios.
Mhm.
So we practice it. We understand it's all about practice and be able to repeat the actions that we've gone through when we do have a high water event, which right now we're in a high water season. So the chances of this occurring is real.
Mhm.
And I'll say back in 2019, we had a high water event, and we actually went through we stood up the organization, and they went through the process. And afterwards, we had a debrief, and we learned from how we can do that better next time. So
Mhm.
every time we go through these things, whether it's the drill or actual event, we practice and we have that discussion how we can make it better next time. So yeah, you will always have human performance errors. Yeah, I get that. We all fallible to that. But you try to put enough rigor in your practice, your procedures, that those are to a very minimum.
Mhm. Mhm.
Thank you very much.
Jason, any thoughts from the Santee Cooper perspective? Up, I see Bob coming in. I guess a fundamental question I always have is, was there some deficiency in the method? I mean, was that even a realistic method? You know, was it really an error, or was it a problem with the method itself? Jason, any thoughts on that?
Yeah, we're very similar to what those guys do. Raymond and his group. We have a corporate incident management team, and that breaks off into a dam emergency preparedness group, and we do exercises with public officials and et cetera, through different counties, because we're in several different counties. I guess getting in and reviewing those to make, just like you said, to make sure the methodology is correct, from the beginning, and then building that up into individual, I guess, accountability is kind of where we would focus on.
Great, thanks, Bob. Any thoughts on that?
Yeah, just to pile on, I guess, with what these guys said. One thing we are doing is a tabletop and functional exercises, I guess, to actually exercise these emergency action plans. So over the years, we have seen, as Jason is saying, like there's many counties, there's many staff, and sometimes there's a lot of turnover on that side. So we want to make sure that, when we call them, they actually know what to do. Like, what is this red book? What's my action? What do I have to do? So I think the tabletop exercises are good, and it really doesn't take a lot of effort. And basically do a round table, and it's like, well, what would you do in this scenario? You give them a scenario, and what would you do? And it's really going agency by agency, and folks learn. It's not just the folks, addressing it, but everybody else kind of says, oh, that's what this agency does, or that's how they would react. So I think that's one thing. We actually are required to do full-fledged functional exercises, which steps it up like another level. And I think that's helped. But to what has been mentioned earlier, we have a lot of policies and procedures, and it's really putting them into action. And testing them and exercising them. On the canal side, we have some movable dams that we actually have to lift out of harm's way to let the river go through, because they weren't really designed to be overtopped. And it's a very unique design feature, but if we didn't lift those up in time, those dams could be overtopped. So it's a critical function for us to exercise that. But many of these are written down, and it's into our work orders that we have to exercise these each and every year. But I think that's how you get better, and that's how you really train folks as to what does this. So that's what I had.
Great, thank you. Bing, did you have a follow-on question, or?
Oh, great. That's really helpful. Probably a follow-up question is like Bob just said, that's really interesting, a very good example. If you have an incident, I recall you mentioned that you have a gate, the guard gate, and you can drop down if there's a break in the fall, and then there's so that kind of response, I'm wondering how much the computer-based the decision system, decision support system, or decision making tools, whatever you call them. So how much they will be be part of those decision and action, and that's mainly based on the database monitoring. You make you quick call. Yeah.
Yeah, I would just add to that thing that we have, a lot of water level sensing devices out there, and we're kind of relying on those, as well as during the actual navigation season. There's folks out there that are actually on site and monitoring the situation. So we rely on the public. We rely on some of these sensors to be that trigger. What's the trigger that sets this whole thing off? But then it's like, once we know that, sometimes part of our plan is we actually have to verify that is a case, right? It's not just a prank call or something like that, but it's actually a case. So we actually have to exercise the response time, and we're working with the regulator on that. Like, what's the response time to get folks out there to actually, accomplish what we said we were going to accomplish? So there is a lot of sensors involved, but it's actually, what do we do once we get that information? How quickly can we respond?
Just to add on to that, Bob, we also have a main control center that watches all our rivers and lakes, but we also have cameras at all these facilities. So when we do get an alarm, high water alarm or some sort of indication, we'll flip those cameras on to visually see, and that helps the response time.
Trust and, I was just going to say, trust and verify.
That's right. Trust and verify. And then if it's really a true issue, then we'll dispatch. If it's after hour, we'll dispatch and send somebody out there to address it. But obviously, we have a manned 24/7 control center that watches and monitors all of our hydro assets and that's, I think we implemented as part of our emergency response too, is that these are all part of our security. Is also security, but mainly for monitoring for the water.
Great, thank you. Any other questions from our attendees today? Otherwise, any parting thoughts from our panelists? Ray, do you have any parting thoughts? It's okay to not have any. It's Saturday.
It is Saturday, but I have to say that safety is a really big issue. It's not only, and we have to be really diligent. And I could see everyone having attuned to it, but there's complacency that will build up because we do it all the time. We talk about it all the time, and we got to put it into practice and try to work out the complacency that builds up, because we do it all the time. We feel like it's part of our nature, but sometimes we forget.
Maybe we can convert that complacency into like high level of safety complacency. So you're being complacent, but like it's a positive thing.
That's right.
Jason, any parting thoughts?
No, I agree. I mean, it's I look at safety as it's so much more than just rules and regulations. It's it's getting those relationships and creating that environment where people feel comfortable bringing an issue to you because they know you're going to take care of it, and if it's something that needs to be done, right? But it's working within that organization. I mean, there's tons of books and articles about leading with safety, and if you lead with safety, you automatically got common ground with those around you, right? So, but it's just creating that environment. You got to hold people accountable, and it goes on and on. But there's I think that's probably my biggest thing I take away. But I'm sorry I missed the other presentations for the most part, but.
Yeah, great. And last but not least, Bob, any parting thoughts here this Saturday?
It's been great. I think there's been a lot of current themes here that tie these together, and it really kind of centers on the culture, right? The safety culture, and really having that open environment where folks are willing, right, to bring forth what the issues are. what their concerns are, and I think that's how we all get better, right? As we just learn from ourselves, so that we're not complacent. We don't rest on our laurels, and we just look for that continuous improvement. And you know, I just looked at that one slide that I saw with the Swiss cheese, we call it, right? The Swiss cheese. I think you know, if all these things line up, then you're going to get to some significant event. So, you know, that's that depth and defense. It was a very good slide, you know, that really displayed that. And, you know, we've referred to that on a number of occasions as we're trying to build in those layers of defense so that, you know, it doesn't line up and we lead to that significant event. So all in all, a very, very nice job by everyone. Thank you.
Yeah, great. Thanks. So also for the attendees here, you know, feel free to submit requests. If there's something you need help with or want more information on, feel free to use us as a resource. You know, like I said, this is hopefully the starts of a longer conversation. So don't be surprised if there's a follow-up workshop or more resources coming out. You know, maybe we can make this an annual event to, you know, the support group for the safety-minded folks. But I think there's a lot to be gained here, and I think it can be a positive thing as opposed to some negative thing. And thanks to our speakers today for bringing life to these ideas and making it, you know, a shareable experience. So it's not just some crazy idea in someone's head, but, you know, people are actually out there practicing this stuff. So thank you again, and to all of our attendees. And I think that concludes our show. So thanks so much, and go enjoy the rest of your Saturday.
Thank you, Rune. You guys have a good afternoon.
Take care.